Hello world and welcome to Code or Not to Code. I'm Meli Eva and I'm very happy to be here today. And as always, I'm here with Stefan. How are you doing?
I am doing great. Well, during our tour de talk the last couple of weeks, this has been amazing. This has been fun and also preparing for it. But I'm really, really glad to be back.
Yeah, same here. It's been a long time. It's been quite a few weeks. For those of you who've been on the show before, thank you for waiting for us and giving us the time that we needed. And if you're new to the show, well, Stefan and I usually do this every other week. It's kind of a bi-weekly excuse to get together and code together and learn with and from each other because, Stefan has quite a few years of experience in the field. I'm a bit of a noob still. So, we have definitely different kinds of experience in the field, and we always build some fun things live on the show. And live coding is always fun because there's always something, some sort of risk, and the risk is also what makes it exciting. But yeah, the last couple of weeks we've been super busy. Sorry, what were you saying?
I would claim, since you mentioned noob, I would claim you are continuously
I
shedding.
just want to hide.
You are continuously shedding that. That's the correct term,
Yeah, exactly. I've not quite shedded it, but I do. Like eventually I will stop introducing myself as that, and I will sort of like step into the light of a no longer new person, intermediate developer, hopefully. But yeah, it's been exciting. Oh my God, hello Eric, so nice to see you. It's been ages. Thank you so much for joining. But yeah, it's because that I actually did, a little career change a couple of years ago. So like the entire coding world still feels like it was only yesterday that I started. But I also realized that, 3 years ago, on my very first day, I was like, oh my God, there's so many new things. I have no idea what I'm doing. And 3 years later, I've learned so much. But still, every day I go to work and I'm like, what is this? I've never seen this before. What's going on? So it's like, there's always new things coming up, new challenges. And that's also, again, part of the excitement, I suppose.
Even after 15 years, you may, well, depending on the challenge, but if you choose the right thing, that even in 50 years, you will have a similar feeling. Yeah.
I know, but at some point I have to stop. I have to sort of stop introducing myself as a noob, but not today and not next week, not this year. But yeah, so we were offline for the last few weeks because Stefan and I actually, went on tour. We went to two .NET conferences and gave two, it was two different talks, but in NDC, we went to Oslo to their NDC. It was my first time in Norway. It was really, really exciting. And we had a wonderful talk there in room 1, which was huge. It was huge. It was so funny because obviously Stefan has been to quite a few conferences and he was like, yeah, no, NDC is great. You're going to love it. It's super nice. And he made it sound so lovely. And then I get there and it's huge. Every room was massive. And we were there like a day before and they had like an event where you could already see some talks. And we were sitting in and I was like, oh my God, these rooms are so big. And then we went to room 1 and it was even bigger. I was like, no. But yeah, it was a super. We did get a picture. We were up bright and early. Our first talk there, and I look so smiley and happy there, but I was so nervous. You can't even imagine my heart rate at this point. But no, it was a wonderful experience. Like the entire team, like the NDC team, but also like the team that were in room 1, the camera and sound people were really, really amazing. They handled my nerves and everything so well. And obviously the audience was amazing and really encouraging. And I think they really liked the talk, I hope. What do you think? What were your feelings?
Well, we got some from NDC. You always get this feedback in these cards, but you said I shouldn't give you that feedback, so I can't see anything, not even live.
Yeah, I got so scared.
Unless you lifted that embargo, but yeah.
So yeah, because for those of you who've never been to kind of NDC afterwards, yeah, you get like the green, yellow, and red cards that every audience member can like put into a bowl. And obviously, green is good, red is not so good, yellow is meh. Which, you know, if you're an overthinker like me, meh is like the end of my world already. so I was really scared because there were some talks that I thought were so good. Like the content was amazing, the presentation, like the slides, the sort of like general pace and storytelling was outstanding. I was like, oh my god, this is the best talk I've seen all day. And then I walk out and I see like yellow and red cards, and I was like, oh god, what? Who? Why? Which talk did you go to? Did you get the correct bowl? But yeah, I mean, all of the talks, we saw quite a few of them, and I honestly have to say they were incredible. I think I mentioned to you before, because I'm also like, I have this like slightly evil side of me where I was hoping to see like a really bad talk so I could go in and be like, at least I didn't do it that bad. But actually I didn't. They were all really, really outstanding, and I learned so much. I was also thinking that, you know, how can you have so many tracks and talks with so like, how do you even find that many topics? It can't be that every single one of them is like really cool. But I don't know, maybe I just went to the right tracks, but all of the ones that I saw were really, really outstanding. And, you know, I learned a lot about like .NET, but I also learned a lot about presenting and about, you know, just I don't know, being a decent human being. I remember there was a talk about I would talk about like reading other people's code and being, you know, mindful of different perspectives. And I was like, oh my god, this I feel changed. Yeah. It was awesome.
We also got some pictures of us in action, right? Let's see. Well, I guess, yeah, we kind of both nervous, I suppose.
I look a little bit nervous. Yeah. But the room was also full of people. It was pretty cool. Oh, you can see the little duck in the previous one. It's really cute.
Oh yeah,
the red duck. There was some of our props.
We brought an army of ducks. Yeah. Oh, I forgot it outside. Yeah, but I think they come later in the slideshow.
Yeah.
Oh, so
there
yeah,
you
okay.
are. Also
so
with your little duck.
Over there. Yeah. Oops.
Storytelling, guys.
Where eventually then it ended up over there.
Yeah.
How many ducks have we had? The army of ducks, it served as well, like 8 or 9-ish?
8 or 9. And I was so happy that we didn't get searched at the airport, because we had them in our like carry-on luggage. And like, how do you explain this? It's like, why do you have an army of ducks in your backpack? It's like, I don't know. There's this conference. But yeah, we even got ducks at the conference as well.
Ah, yeah.
So the army, even like on the flight back, we had even more than the ones that we brought. No, it was really awesome. Like, if you've never been to NDC, definitely worth the trip. Yeah, and we saw familiar faces, people that we had on the stream as well. We saw Dennis.
Mm-hmm.
Anybody else that was on the stream?
I don't think so.
No.
At least not yet. But maybe next time.
That was really fun. It was my first time seeing in person, so that's really cool.
Mm-hmm. We've also been at Tekorama.
Yeah, literally like the next, like a few days later, like Steph and I just spent all of our time at the airport. Basically, it was really cool because there was also like at the airport we had like a little table. What is it called? Table foosball?
Table soccer? Table football?
Soccer. This thing at the airport. Yeah, and we played a lot. But yeah, then we flew to Antwerp, to Tekorama, which was also quite an experience. So Tekorama, the organizers, I don't know, they have like a whole concept, and they sort of have this massive cinema complex. And we have cinemas in Vienna. I thought it would look something along. And you said that like all the talks would be in like cinema rooms. And we have like cinemas, and you've got like smaller rooms and large rooms. No, Antwerp was insane. Like each and every room was huge. I don't think I've ever been in a cinema that big ever in my life, and like each and every room was massive. And it was actually really cool because the chairs were super comfortable, and if you're like sitting all day, that makes quite the difference. But you can also see they're quite wide, so like the same amount of people in those seats like looks much more intimidating than when they're just like on just little clappy thingy chairs. But yeah, it was really, really cool. And it's also the thing that got me in the first talk that we did there is that because it's a cinema, there's also like once your talk starts, it's just silence, because obviously the walls in cinema are also like soundproof and stuff. And it's just, I don't know, a couple of hundred people in a room, and then it's just silence. And then I'm supposed to go on stage and say something. It was so scary. It was so scary. But again, the team was super, super lovely, and the audience was amazing. Everyone's the vibes are just so great. Everyone's in such a good mood, and everyone's there to learn. So like we also had a little bit of audience interaction. We had some quizzes, and it like most people participated, or like I don't know, quite a few participated, and it was really fun. And I think that the theme was sports. And so we also did quite a few like sporty challenges between talks, and they had performers, and it was like a whole experience. Like it wasn't just a conference; it felt like a conference in Disneyland, kind of.
They have D&D. They also have what's the word? Actors.
Just
doing
performers.
sports and performers. Yeah.
And no, it was really cool. And we did 2 talks there, back to back, kind of. One of them was again really early in the morning. I always remember that because I'm not a morning person. I was so tired. But it's sometimes good to be tired, because then you can't be that nervous. Because if you like, do you remember the first talk that we did in Tekorama? I was literally like, I couldn't even. We went to watch a talk just before ours, and I couldn't even focus because I was like so nervous. And I kept telling you, oh my god, I'm so nervous. Oh my god, I'm so nervous. And I felt like, that's not a good partner. If I felt like I was making you nervous now.
Well, this is how it is.
I should be giving you confidence.
It was the first gig. It should never go away. It will get better every time, but it should never go away.
Yeah, that's again us in front of room 9.
You did very, very well.
Thank you. It was really fun. I always get so nervous, but as soon as it started, I was just like into it. And I actually had a lot of fun. Like on stage as well. Like I knew that I'd have a lot of fun at the conferences, but actually being on stage and presenting and giving our talks. And I think, and also having the audience sort of be there and interact with us. Because, I mean, you guys know how much we love it when you guys interact with us on the stream. Like, imagine this in person. Like, we were thrilled. We were so happy. And the thing about Tekorama is also you get a little trophy, which makes you again feel super like, I don't know, proud after you've done your talks, and you can kind of see the trophy.
Yeah, I see it already.
Oh my goodness, there it is. That's it, a little Tekorama robot. And yours, so I can see yours in the background. But wait a second, yours is wearing the wrong hat.
Yeah, that's the last year's edition. Actually, I haven't. Well, I the only thing I did, I took a look at if it's in there, but I thought I'd do a live unboxing of the value that is in there, if you catch my drift. that I'm not gonna put on my evaluation stack of books. Okay, that's a terrible joke. Now, you know what's gonna be fun if I break it.
That would be so fun. Because they're kind of like the Eurovision trophies. They do sometimes break. We've heard it from. Oh, there it is. No. Hold it in. No, I need to see it up close. Hold it in camera. Ooh. There it is. It's a little football player. American football.
Oh, it's really cool. And it's also it's
Right?
really it's heavy. Well, it's not like
Yeah, I
heavy, but
know.
it's solid.
No, it
It's
is heavy.
solid.
It
It's
is.
really cool.
Yes.
It now goes right next to the last year's fun fair Techo bot. Now he has a brother or a sister. Or
Aww.
what is siblings of robots called? Robling. I don't know. Well, the puns went as bad as anticipated. The unpacking though went quite well.
Yes, it survived the journey. Can you imagine if it because did you have it in your backpack on the way back? Like, imagine if it just on the plane it got broken and you wouldn't have known until now. That would be funny.
Well, I checked before, but that would be.
Oh, did you? Okay.
No,
Wow.
I just opened to see. I didn't put it out, but I wanted to check if it's alive. Yeah.
Okay.
Well, I think I put more care in bringing the robot home than, I don't know, my passport or something.
Yeah, I mean, the
That's
passport
actually
is
not an
replaceable if you lose your
That's
robot.
actually
Because
yeah.
they
That's
only
quite
have
unique.
they
It's a
have
limited
each year they
edition,
have a
yeah.
new exactly.
You're
So
right.
made the right choice. Your priorities are straight, so that's good. Yeah, I guess that was our. Do you have any fun stories to tell from any of the conferences? You actually have been to another conference since, because Stefan is, you can't stop him.
Well,
he just keeps on going.
I've been the first time at DevSum in Stockholm, which is interesting at this time of year because in Stockholm it doesn't get super dark anymore.
Mm-hmm.
So that was an interesting experience. And what I'm looking for? My name actually, yeah. So I was talking about async and await.
Uh-huh.
And all its little intricacies, which was a bit of a follow-up from our pattern session, because there's also with async await there is patterns involved. And since we talked in the previous episodes, well, we had a lot about memory management. Now, recently, in our offline experience, we did a lot about patterns. So we thought we perhaps combine now patterns with memory, which then leads to the no, that's the wrong side. Wrong page. Okay, that's embarrassing. Is it not? I thought there was a page for that. Is it not? The .NET Dispose Pattern. There should be it's a pattern. There it is. I should have clicked here. Yes, the Dispose Pattern. Okay, that went poorly.
No, that's okay. That's what I said. This is why this is so fun to do live, because, because it's more relatable this way, and yeah, exactly. So we did one of our talks was about C# language patterns, where we also showed the Dispose language pattern. So should we start off with that?
Let's jump right
into
it.
Wait. Are we jumping into this, or are we having a trivia?
Oh yes, yes. Trivia question.
See, this is we took a long break, and now we don't we get the order all wrong. We used to have this in our bones, but no, not anymore. Yes, so if you're new to the show, we always have a little trivia session. Oh my god, we had such a fun time, Eric. It was really, really good. But yeah, we missed you. Let's stream.
Oh yes, indeed.
And all of this. Yeah, and the trivia section.
Good to be back. So, what you can do is doing a using declaration, our disposable. Let's create a new instance of our disposable type. Let's create our disposable type. As always, I like to make them sealed. Implement disposable because, the compiler complains here. In order to use it in a using declaration, it needs to have the disposable interface. And let's implement the method. Maybe let's just do a constructor where we get this logger. Well, so the application actually perhaps, well, let's come to the application later. We just forward a logger, and then in the dispose, we log information. Oops. Disposed. And oh yeah, we get the live share redness again. It's been too long. It's been too long.
It's been too long.
And maybe let's move that in here.
I guess for those of you who are not familiar, we're using Code with Me, which is pretty awesome because I can actually join Stefan and I can also write something. Hello. But yeah, it just means that sometimes we get little red spots that aren't supposed to be there. Well, yeah. But you learn to ignore them.
Indeed, yeah. And yeah, a little trivia. Actually, now a little bit of a quiz, since we talked about pattern a lot. So since the compiler can kind of anticipate this dispose method, would this, I'm not commenting out to not give it away, but the question where we are now building up to, would this work without implementing the dispose method? Yes or no? Let's build it up. Would you like to start with building up to discover what is this dispose potential pattern, and if it is or is not a language pattern to some degree?
Building up to it, yes. Okay. Well, usually, wait, are we going? Should I write so what I want to do is I want to have a look under the hood into like the IL view, because that's where you can spot patterns pretty easily if you know what you're looking for. But so for that, I would probably need should we like have the example with the for each?
That sounds good, yeah.
Yeah. So I like this because we had the example in the talks, but they're also quite a long way away. So I hope I can
been a while as well.
Yeah. But yeah, can I just put it here? And I'm just gonna already sort of think a little bit ahead, because we could just have like a normal for each, but I'm just gonna write a method called get items async. Actually, let's not do this.
Let's do sync first. Then we take a peek at the
but we can also write a synchronous for each like this, right?
We can do either, yeah. But let's start with the synchronous version, and then let's go more complex with the asynchronous one.
Okay, but can't we have a synchronous for each with a method in the for each as well?
Yes. Then just without the await.
Exactly. Oh, without. See, yes, get items, right? That's what you're saying.
Yeah, exactly. Yes.
Do you know why I said it though? I didn't even like consciously say it. It's just because that's what we had in the talk, and it's like
yes,
my memory.
Yeah, we had a different journey.
I was so scared.
Point, yeah.
Yeah, because I mean, if you're a regular to the show, you know that I really I struggled with typos, so I practiced writing like all the method names so many times. I literally, sometimes even during the day, I would just write get items async to train my fingers to not make a spelling mistake on a screen in front of an entire cinema. But yeah, get items. I'm just gonna do an Alt Enter here and create a method down there, and here I'm just gonna do a for with an up of, let's say, 5, and then we're gonna yield. Oops, not yield break. Yield return I. Easy.
I'm gonna change this to a
y.
Why here's well, it's correct, but I guess it's preferring the non-generic version. But yeah, with the generic version now, we're returning an anomaly of T, which is now turning this method into iterator method, which is kind of a state machine. And for every state that we get out, we return 0 through 4.
And then what, should we log some information or should we print to the console?
Let's just do the item,
Okay. Log information item,
actually, I haven't. There was a bit of a. Have you used logging before, or the iLogger interface?
I have.
Because that works a little bit different, because we can't just pass in any object. It needs to be a string. But you shouldn't really do. Yeah, we could do that, but we shouldn't really do. There is actually, I should have mentioned this before, but there is something like structured logging. So what you usually do is you don't do an interpolated string, but you do a template string, something like item colon and then a placeholder. You could also give this a name, I think. Let's call it number or item, and then you pass it as an argument. Because now we have both the original template string and also the data individually, which depending on the logging provider and the backend you use, you can now search by this item value. So just that we use this logging interface correctly.
Yeah, that's really funny, because I've seen definitely this sort of that before, and that you use it like that, but I didn't know that you had to use it like that. I thought it was just like a convention.
Actually, there are some performance pitfalls to that. And
no way.
we were just before we started, we were wondering, because we wanna now go from the memory over our talks to a bit of a what we promised, more performance and benchmarking, and trying to build up a bit of an angle there. And I think I just found it. We just found it, so I'm super happy. But I'm totally
awesome.
What's the word? Spoiling. It's 2-3 episodes away, but teasing. That's the word. Anyway,
okay. But that's what we always
we will uncover
doing.
we will uncover a bit of a performance. I mean, I have a plugin in Wider that shows me here an underscore. It's not ideal when it comes to memory allocation, but we come to that in a future episode, and we'll measure that and fix it. Anyway, functionality style, all is good. We print, or is it? It should. Is it running? We print the items 0 through 4 via the logger.
Awesome. Now, if we go into the IL view, I think you have to do that, right? Because you can't see it if I do it.
Yes, indeed. Yeah. So I can click here. Wider supports that out of the hood. If you're not on Wider, then what you could do is to go to the good old sharp.io.
Good times.
Maybe can we just, and then use the IL or decompile view here. Or there is also razor.lab.fyi, if I recall correctly. Or is it lab.razor.fyi? I think it's razor.lab. That's something else, no? Is it lab.razor? It's something with FYI. Razor. Now I'm embarrassing myself. It's something else, right? Anyway, something similar to that. I'll figure it out later.
Okay.
If you're not on Wider. Anyway, so if we get the view right, what we see is that what this for each is now translated into the for each pattern that we dissected in our session at the conference. But what we also see, since we were talking a bit of disposable, there is a dispose actually coming from.
There is a dispose right there on the enumerator. That's obviously from the for each pattern actually. And the funny thing is that we sort of mentioned this as well, because for the for each pattern, you can see out of the when you write it like this, it does call dispose, but it's actually not necessary for the for each pattern. You can also write the pattern without it, but obviously you shouldn't. So if you want to have that in your custom for eachable, then you need to add it. And the easiest way to do that is obviously with the interface. But if you go a couple of versions back, like the language is always evolving, and things do get easier and easier, which is good for me. I like easy. But like, for example, if you were working with a ref struct, they weren't able to implement interfaces until I believe it was C#13 or something.
Until yes.
Yeah, I always have to look up the version.
Yeah.
Yeah, exactly. So how could you?
Yes. Sorry, I'm getting confused. Yes, you're right.
Yeah, I know. It's like it's so many, all of the numbers, all of the version numbers in my head. So like, how would you do that in a previous version?
Right.
With the pattern?
Let's actually do that. So let's travel back in time. Let's go C# lang version to C#12. Where now, we were talking about disposable. Oops, I should stop running. Where, well, we can implement the disposable, and if we comment this begin, everything is fine. But what if this was as you mentioned, a ref struct? Now with C#12, it says can't use ref struct interfaces yet because we need language version 13 or higher. So how could we make something I guess I give it away because the compiler error is gone already. That was poor. Anyway,
the compiler error is because like the disposable is still.
Yeah, well, we
can get rid of that.
Yeah, right? We can't just get rid of that, but at the usage we don't see any error anymore.
Oh, so
totally gave that away. So for ref structs, dispose is a pattern. And we can launch that, and we'll actually get this dispose method called, there it is, disposed. And we can also confirm that by taking a peek at the IRL. When we dissect the using declaration here, we see that this is what the compiler generates out of it, creates this instance, then does a try, there it is, try finally, where in the, wait a minute, that's, okay, sorry. The inner try finally is the try finally from this for each.
Yeah.
Maybe we should maybe I comment this for each out to only focus on one thing, because that was the inner for each, and the outer for each of what we saw was our using. Removing the one, so we only have the one. So we see that whatever comes after the using now is part in the try block. And then at the end, we do a finally dispose to ensure that this dispose is called, although our disposable does not implement a disposable, but fulfills the shape of it. If we were to rename this dispose, like to an uppercase E instead, where C# is case sensitive, so this is now a different identifier than the dispose with a lowercase e at the end. Now, this will not compile, and the compiler will say it must have a public void returning dispose instance method.
Yeah. And you might, I mean, this is also like really handy because there's also like this philosophy about less code is, always better. So it would sort of also make sense. I mean, other like structs or like classes, they can actually inherit from interfaces. So could we just change it back and leave the shape as is? Would that still work?
If we now change back to a class, it will not.
Doesn't. So I think we already mentioned it before, but like this literally just works for S structs because they had this sort of they weren't able to inherit from interfaces. So how exactly a constraint, and so this was kind of like a little workaround. But Stefan, we're living in the past because we're not. We are. Yes. We do have C#13 available, and we actually can have also REST structs inheriting interfaces and doing all of that stuff.
Oh, yes.
But with C#13, we don't necessarily need the interface, right? We can add it if we like, but we don't have to.
Yeah. I guess it's good practice in cases of if you have a method like a public. Now we come talk about constraints. Now we're coming to an anti-constraint. That is going to be fun. Maybe we have a method that is that is called dispose, which is generic, that takes a t where this t. Now I need to think. I haven't written a generic constraint in a while. Where these t's are disposable, so that we can call in this. Let's call this let's call it invoke. To have a different name, not use the same name all over the place. Let's call this invoke dispose, where we can now do dispose.invoke, dispose.dispose. Let's call this disposable. Naming is hard. Disposable.
Yep.
So because of this generic constraint, we say this is disposable, so we can actually now call this dispose in this method. And we could now also pass our instance of disposable there. Well, if it wasn't a ref struct, if it was like a regular struct or a class, we can just pass it in there. The thing is, do you notice what's happening? We have here a struct.
Yep.
That is implementing an interface.
Yep.
And we are passing an instance to here, where we constrain this to t. Actually, let's do something different. Let's not make this generic, but let's actually say, let's make this an let's make it accept disposable. So any disposable. Do you know? Maybe I should move this down so that we see it on the same screen. So the instance of our disposable, that's a struct. And we call here a method taking it by interface. Do you know what will happen here? Something's going to happen because I already see this blue line under now. Do you know what's happening here?
Something with memory allocation.
Yes, and in particular, maybe I give a hint.
Boxing.
Yes, I was about to do that.
I already heard the box rattling, and I was like, yes, I know it.
Because when we cast an instance of a struct to an interface that it implements, like let's make disposable, oops, wow, I can't type. And we see here this plugin that I'm using for Rider is mentioning that's a boxing allocation because our disposable, which is a struct, we are casting it. If you cast a struct to object or to an interface that this struct implements, you will box it. So it's an allocation, and we're actually putting it on the heap. Now, ref structs are super, super strict. They cannot be on the heap. It's like, a class is always on the heap. Well, that's not too true with .NET 10 coming up anymore, because the JIT may do some optimizations where actually some instances of classes, depending, there's a lot of constraints to that, but may also be just on the stack to avoid heap allocation. So .NET is getting faster and faster. But in the good old days, a class was always on the heap.
Yeah.
A struct may be on the heap, can be on the stack, but maybe boxed onto the heap. Yep. And the ref struct cannot be on the heap. That's always on the stack. So we have a couple of constraints. So with a ref struct, we cannot box a ref struct. So assigning a ref struct to an interface this is why actually before C# 13, it wasn't allowed to a ref struct to implement interfaces, because if you assign it to that interface, we are boxing. The compiler has now lifted this restriction, but still doesn't allow this assigning portion because that's boxing, and we can't box a ref struct to the heap because it must live on the stack. That's what the ref struct. It's a by-ref-like type, and by-ref-like types must live on the stack. There is some lifetime constraints. Perhaps at some episode we'll take a look at span and can unveil why that is, because we could violate some lifetime rules about memory. But how do we now call this invoke dispose method with a ref struct that is implementing that interface? Well, what we could do is make it generic, what we had earlier, where this T implements the disposable, But it still doesn't work. Because what could technically happen is that if we make this an instance method, we technically could have a field, private I disposable. I call this now escape. And now I assign this disposable that we pass in to this escape, which means if this was a struct that we pass in here, we now would assign it to a field that is a member of a class. And a class may be on the heap, or usually is on the heap. So again, we would now move it, it would escape from the stack to the heap, where we would violate the lifetime rules of a ref struct. So in order to still allow that, what we can now do is an anti-constraint. Now that's fun. We can say allows ref structs. Now that's the opposite of a constraint. That's an anti-constraint, which is now making the callee more constrained. So we now get the error here. This disposable now is basically scoped to this method, and it cannot escape that method. So this assignment here is invalid. Because it would escape. So we can't do that. And because we now have this constraint on this method that whatever we pass in here, even if it's a ref struct that must be on the stack, cannot escape the scope of this method, so always is on the stack, we can actually now call this invoke dispose method with a ref struct. Because it implementing that interface. But yeah, that's the cool thing about ref struct. And whenever you see something with allows ref structs, that means that the generic T may be a ref struct, such as our ref struct, or for example, a span, read-only span would be a very typical one. But the method that has the allow ref structs constraint now cannot leak that parameter or this argument out to a larger scope. If that makes sense. And I'm not sure where I tried to get it. Oh yeah, implementing interfaces and such. Implementing interfaces and such. Yeah, there is quite a story to that. And the compiler makes sure that if it's a ref struct that implements an interface, still it doesn't escape the stack-based constraints.
Yeah. So funny. Ref structs are actually really, like, there's so many times where we had long discussions about like ref structs and their, I don't know, uniqueness in a way. But the thing is, I've actually, like, at work, I don't think I've ever used one. Is that bad? Should I start?
No. It's very exceedingly unlikely that you ever gonna declare a ref struct outside of an educational session.
Okay.
It's exceedingly unlikely. Well, it's very unlikely.
Okay, fair enough.
As application developers, you rarely need it. If you build a framework or a library, then depending on the framework and or library that you're building, then you may need it. Especially when it comes to high performance code and you want to do something with stack allocations and such, where you actually have to ensure memories on the stack to avoid some heap allocations. So when you do high performance work in your application or high performance frameworks, libraries in general, then you may need it. But I mean, it's unlikely that I'm gonna build my own ref struct. I like to do it in educational sessions so that I understand how it works, so that I understand what span, and because it's it's actually likely, it's becoming more, with every .NET version, it's becoming more likely that we will use span or read-only span of T, which are ref structs.
Yep.
And these are very likely, and they have the very same constraints as a ref struct. And so you can, to some degree, you may want to utilize some of these generic anti-constraints so that you can make use in your methods of span and read-only span. So you may be using ref structs from a consumption point of view. It's unlikely that me or you will build a shared ref struct. It's unlikely. I'm not saying it's, who knows, maybe in 5 years I'm proven wrong. But we definitely want to use them.
Okay.
Yeah, talking about patterns, let's now go to the asynchronous world.
Yes, it's async time. This is too easy otherwise. Wait, my for each is commented out.
Oh yeah, let's bring that back.
So I'm gonna wait for each. Get items async. And should I create a new one or should I just rename this one?
Let's rename this one.
We don't need it anymore, right? Yeah. But then just before we yield return it, I'm just going to use task.delay. And we do always like 1 second, right? So, or should we do?
That's fair.
Yeah. Okay. Fair.
What is missing? Or what is? Well, there is 5 characters missing.
Why?
That's unhelpful. Trying to be helpful. Well, we are returning an enumerable, but an enumerable cannot await for each, but only for each. So we need to do an async now enables. Now we can await.
I got it.
Delay. So we actually need both. Yeah.
Yeah.
So we need the method to be async, but also if we want to await for each something, it can be async because enumerable is synchronous. So we need the asynchronous version of an enumerable, which is the async enumerable exactly, because that has the different pattern where the move next is async, and now this is for each. Well, I guess we're missing just the async keyword here, and now we're in async land. And when it comes to async land, there is again, because async state. Currently with async, there is a state machine involved, and the state machine is, I think, on the heap, or maybe on the heap. So we can't use ref structs to some degree. A ref struct can't cross await boundaries. So we are declaring the ref struct here, but we implicitly have a dispose at the end. So we are crossing, this ref struct is crossing this await boundary, so this doesn't work. I'm not changing our disposable to a regular good old class, but make it sealed because it can't cross the async await boundary. But yeah, that looks kind of compiling. Let's give it a run and see if we now print with 1 second delay, 1, 0, 1, 2, 3, 4, and then at the end, still disposed.
Nice. But maybe let's have a look under the hood if anything's changed there, or do we want to even like because this async state machine is a little bit intimidating, at least for me at the beginning. But yeah, we scrolled past some patterns already.
After many years and also giving talk about the state machine, still intimidating to me. It never goes away.
Never goes away.
But eventually...
Where is it? Yeah, there we are. Dispose.
What? Actually, wait a second. I think this is... This dispose. We need the dispose of the iterator. So this is here.
Oh yeah, there it is. Dispose async.
Because it's dispose async. Yeah. So I'm now wondering if we could make our disposable await using. Would you mind giving that a try?
Sure. How do I do that?
Well, basically, it's super similar to the enumerable, where the enumerable become async enumerable. The disposable becomes.
Let's just go dispose async.
Almost. Well, the interface is now no longer the disposable because the disposable is synchronous. We need the async disposable,
Easy.
And the return type of dispose async is not void, but what's the async equivalent of void?
Oh my goodness. The async equivalent of void.
Yeah. I think I may have asked the same question when we met the first time a couple of years ago.
No way, really? Void async.
I think
No.
So if we turn a synchronous method that is void returning to an asynchronous
mhm.
method, then the return type changes from void to
Task?
yes. Almost
Nice.
yes, because in this case it's not
Because
a
in
task
this
but
case-
a value task. But close enough.
Damn it.
Because
Okay.
the value task is a value task. Oops, excuse me. I hit one.
It is. I remember now. As actually the moment that you were referencing.
Yeah. actually, no. Thinking
I was
back,
completely new to this world. I was happy that I knew what void was. I was like, what? But yeah, I guess, yeah.
well, I guess that's baptism by fire, right? I haven't scared you off the day we met, and now we are doing live streaming and speaking conferences. So I guess that paid off.
Definitely. I think there's no other way to kind of teach me. I sort of like need that. You can't put too much gloves on.
Well, I am partially.
I need the heart rate. You know, what is going on? What? I need that. It helps my brain.
Well, to be fair, I am partially sorry, but only partially. Oh yeah, so we now have the asynchronous version. Yeah, because the value task is basically that's a struct version of a task, where in some cases you can avoid allocations, and this is a guideline that will evaporate in .NET 14 or 15 when we switch from compiler-based async and await that we currently have with the async state machine to runtime async, or previously it was called async 2, where the guideline then will be everything should be a task or task of T to yield the best performance. But yeah, a lot of guidelines will change with the new version of asynchrony. Anyway, still currently .NET 13, .NET 9, the async disposable is using a value task because it can be more efficient than a regular task.
So do you just return a new value task? Yeah. Or do
what do you do? You can either do that or just return. You could also just return a default. Or if you want to be explicit, you can say value task dot completed task.
Nice.
Where value task dot completed task, if you take a look at the implementation, is just doing new value task.
Okay.
Which is the equivalent of default. So whatever. It's not 100% style, but it's mostly style.
Okay. So no benchmarking needed here. Okay.
I don't think we'll be able to measure anything there.
Okay. Fair enough. All right. Let's leave it at default then.
And yes, now I'm wondering, since we're talking about pattern, actually let's see it working. Let's see it working that we indeed call. I'm not doing not disposed, but async disposed instead.
Disposed, yes.
And let's see if we with an await using where is it? There it is. Actually, do get the async get disposed called. Now, since we're talking about patterns, I'm not wondering if a similar rule here.
Yeah. I wonder as well, because like it was, so the synchronous was a pattern for ref structs.
Mm-hmm.
Let's see.
But for, oops, I'm still running. But for async disposable, it's a pattern for any kind of type. So we don't see any errors here. We have a class which didn't work with a synchronous version of dispose, but with the async version, it still works, and we can confirm that it still calls async disposed.
Awesome. So as long as you fulfill the kind of the shape, you're good to go. You don't need the interface, and you have less code, and that makes some people happy. Are you one of those developers who like loves to sort of like save every line that you can?
Well, yeah. Well, I would still implement the async dispose actually, because what we can't do if we now have an invoke dispose async, that would be taking an async disposable, which now calls dispose async and maybe even awaits it and does a async value task here. Now, what am I doing wrong? Parameters of type T can be declared in an async method. Cool. I think that's the constraint. Yeah, because when we go with async, we have a state machine, which is on the heap, but we cannot make now a constraint that forces it to be on the stack. That's a conflict. So it must be either. So we can't use ref structs when it comes to async and await because of the state machine. But yeah, now we can't pass our disposable to this method because we are not fulfilling any interface. Because, well, how do we know, how do we promise that, well, we're expecting it to be async disposable. We are fulfilling the shape for this language keyword, but the .NET method from an IL code view requires this interface to be implemented, so we can't. So it's still good to implement the interface, and then this works as well, I guess.
Yeah, makes sense.
But, yeah.
But it's just cool that it gives you kind of a freedom to also do your own thing if you'd like to. So I think it's really, really cool that in for async it's actually a pattern for any kind of type.
So we're talking about patterns now a lot. Now,
yeah,
this was the using and the await using pattern, where the using with ref structs we don't need the disposable interface. So that's a language pattern, as well as the await using for classes and structs to be able to be used in the await using without implementing the async disposable interface. But those are language patterns. There is also patterns that kind of one-time patterns, .NET IL code, kind of code patterns, more on a library point of view, which now neatly, that was my fail there. Where's the pattern?
Yeah, I actually didn't know about those.
Leads us to the dispose pattern. So how do we implement actually now this dispose method that we were talking about correctly? Because there is a couple of intricacies to that topic, and that's just the synchronous version. There's also an asynchronous version.
Wow.
And this is what we now gonna cover in the next hour, because there's also a bit of pitfalls. And I have implemented dispose wrongly I have implemented it wrongly more times than I implemented correctly, because I think I just recently it made click, and I now recently just understand it, how it really works and why it is as it is. It's a bit complicated, but I hope that with the example we prepared, or we're building up to, it makes sense of why it is as it is.
Yeah, well, hopefully. I don't think I've ever implemented it, so this will be a first for me. And if I understand it in an hour, then I think we'll be good.
So I'm gonna get rid of the code.
Everything.
Almost everything.
Okay.
Actually now close the gap. So the application that we have, that is a worker application. So we have a generic host. That's not a web host, but a generic console-based host where we add this worker service. And then we just build and run. And what we can do with this build and run, well, when you just run this application, since this run will not stop until we close the application, or we can also do Control-C or some other signal to terminate the application. When I do Control-C, then the host shuts down. So there's a lot of lifetime when it comes to this application. And what we get is here a hosted service, which in this case is a background service. Well, there's a lot of it. I guess we could do a separate session on that topic alone. Long story short, there is this execute async method invoked when this background service starts up. And the clue is it's a background service, so it's not blocking other services. We could have multiple services running next to each other, depending on the implementation. Anyway, let's return a completed task here just to get it compiling. Now let's build ourselves a resource. Now let's do a public sealed class, our resource. And I would like this resource to be disposable. Now, I'm thinking about having a field, a periodic timer, where we, in the constructor, initialize this periodic timer. Now this periodic timer, it takes a time span for the period and also time provider. So let's do the period also as a dependency in here. Time span period, there it is. Let's forward that. And then what I'm actually want to do with that, I haven't figured that out actually. Let's just, well, the example is quite contrived, but let's just have a method that basically is forwarding the wait to next tick async. And let's have basically the same signature. So we basically just wrap this resource so that we have something, so that we have a resource that potentially requires disposal. Because every time there's a timer involved, usually there is a dispose method to be called. For example, if you have a if you do something like a task completion source. No, wait a minute. Task cancellation. How is it called? Cancellation token source. There we go. Cancellation token source. Yeah. So if we have a cancellation token source is used to get a cancellation token.
Yep.
That's required for cancellation because async and dispose is cooperative, but we will cooperative cancellation, but we come to that. So this is how we can create the cancellation token, but this is also where the cancellation token source, we can also control the cancellation token and we can cancel this cancellation token via the cancel method. The token itself cannot be canceled. Well, not directly, but via the cancellation token source, we can cancel the token that we get out of the cancellation token source. But there is also a method to say, don't cancel immediately, cancel after, let's say, 1,000 milliseconds, something. You could use this for timeouts, for example. And now, if we do something after some point, well, we have now a timer involved. And this is why the cancellation token source is also disposable, and we can call dispose to clean up that timer, that resource in a deterministic fashion. So usually when you have a timer, there is a dispose. That's, I guess, the takeaway. And there is, or when you have something with I/O, like a file stream, or streams in general, usually are disposable because they could be backed by a file stream. Now you have some file-based resources that may interrupt with your operating system. So we're kind of crossing the process boundary from our process to communicate with the operating system. So there's also then resources that may require cleanup. So usually you have disposes there as well. Anyway, now since you have a timer, well, basically this bit of a contrived example, but we will now have basically the same method, which is just forwarding to this wait for tick async. And in our usage, let's just use it. So we will private read only our resource. Let's call it resource. We will now use this logger. So create a new instance of this logger with a time span. Let's also do from seconds. Let's do 1 second. So we now have a periodic timer that triggers every second. And we would like to, we also get cancellation. So cancellation, that's cooperative. We can now say, while this resource that is using the periodic timer, wait for next tick async, where we pass in the cancellation token. Since it's async, we need to await it, which now forces our method to be awaitable. And we can now do every tick. So every seconds, we can now use the logger to log information. Maybe the current time is date time dot UTC now. oh yeah, we should use a template here, otherwise it doesn't make sense now. So, oops, I think there is sort modifiers. So what we have is this execute async that is called, and then in a loop until we cancel this token. In our case, this token is canceled when we hit Control C, so when we close the application. We, every second, call log information. Let's see if it works. And now every second we should get a new timestamp. And yeah, we do 15, 16, 17, 18.
Awesome.
Now, I know that background service implements something with Dispose. Override Dispose. And I know that our resource, well, we already called it resource, and usually when we talk about resources, then there is something that should be disposed, kind of should be something with Dispose. And when we take a peek at the periodic timer, indeed, this periodic timer is iDisposable. So this, our resource, owns a periodic timer. Our resource is creating the timer, owning the timer, and is therefore also responsible for disposing the timer. Now, would you like to give it a try to implement the dispose method / pattern? Well, we'll first build the method, and then we will find out the pattern step by step.
Exactly. Okay. Well, it needs to be accessible. So I'm going to start with public. And then we need a return type, which can be void, because we're not in synchronous land.
We're in synchronous world, yeah.
I'm going to call it dispose.
Yeah.
Good start. I think that's a good start.
Done.
Oops, what did I do? I don't know what just happened. But this is what I wanted to do. Okay. And now we need to dispose our timer somehow.
Yeah, well, we saw that the periodic timer implements the iDisposable interface. So just by looking at the signature, well, we kind of can assume, actually, it's required that indeed there is a dispose method. Cool. But if I now go here, so you're building the type, I am consuming the type. I actually can call dispose on it. Cool. What if I wouldn't have a I now do a contrived example. What if I also want to have it as an iDisposable? Now, for some reason, okay, contrived example, casting our resource to an iDisposable. So it's good practice to also implement the interface, the iDisposable interface. Oops. So not just fulfilling the language pattern, the using language pattern, but also implementing the iDisposable interface on our resource.
There it is.
Wonderful. Now, let's do a breakpoint here, and let's see if that works as intended. Let's see our timer ticking. Oh, I don't want a breakpoint here, but in the dispose. Wait a second.
Do we have a
dispose.
log
there we go.
for disposed?
No, but
no, we should just see it stop.
Just setting a breakpoint, so it's logging away. That's all good. And when I hit Control C, which is now under the hood, canceling this cancellation token. So, this stopping token here, canceling this, we forward this token to our method, where we forward this token to this method, which is now listening to this cancellation token. If cancellation token is invoked, then this method will stop, returning false for this value task. Currently, it's returning true. And as long as it's returning true, we are here in an infinite loop, while true. At some point, it returns false when we cancel.
Yep.
And then we exit this loop, and then also terminate the application because we hit Control C. And this is what should happen. So if we have to Control C, we now hit our dispose method as expected. And cool. We now have a disposable resource. It owns something that is disposable, and we properly implement dispose. Cool. So that's the easy portion of the dispose pattern. Now, where should we go to? Yes. What if, because I made this sealed intentionally, what if, well, I'm not going to touch this type. This is your type. So I'm now give you the bit of a requirement. Maybe let's make a new type so that we can have two windows next to each other. So this is our resource. I'm going to be, how do we call this? Derivative. Is this a name? Which is now sealed. But I would like to derive, now basically giving you another requirement. I would like to derive, because that's an amazing resource. I want to derive from this resource, inherit its information. Also, I would like to have a constructor that takes this timer and is calling then the base constructor of yours. And then I just want to do some additional stuff there. But it's sealed. Cannot inherit from a sealed class. So could you help me? And because this is opening a can of worms, but we're getting there. Could you help me with making our resource derivable?
How do you do that? I mean, just take the sealed away. Or you could no, actually, I don't know. You could Google it.
Well, you knew already. You said it.
You what?
You said it already.
Did I?
Yeah.
Oh no. What was it?
You said take the sealed away.
Oh.
Because sealed is...
I am an overthinker.
Sealed is blocking inheritance. The default non-sealed means inheritable.
Wait, sorry, I'm in the wrong file. I am here. Okay. Yes. Oops.
And now our resource is inheritable.
Awesome.
And we can, I think actually, I'm wondering if IL code is actually showing something like the name inheritable or something. Could be if we go to IL. How is this called in IL code? Public bypassing special name. Our resource. Oh, sealed. Oh yeah, okay. No, it's sealed here. The derivative. Never mind. Okay, IL is sealed. I think the Visual Basic terminology is inheritable, if I remember that correctly. Cool. Okay. Wonderful. But what if I have, because I mentioned file stream. Now, well, this is definitely a bit of a contrived example. I'm not going to build it out. But what if I'm owning a file stream? I read only file stream. File. And I am initializing this file stream now. Well, kind of to some location. Well, this will not work at runtime, but just, go with that. And I'm going to do any file mode. It really doesn't matter. So just that it compiles. Now I would like to dispose that as well. But what options do I have? Since you implement dispose, but you didn't mark it as virtual. So I cannot override your dispose. Well, I could give it a try, but it will say that it's not override. There we go. It will say there is no suitable method to override because it's not it's neither abstract nor virtual. So I can't, because this is basically what I want to do, but I can't. Now, well, making this overridable is actually, well, making it virtual could be one solution.
Yep.
Maybe how do we go from there? Should we connect? Maybe this actually goes there. Yeah. What if now I'm going to do something fancy. Maybe I don't have a file stream. Maybe I decide to do something with unmanaged resources. So I'm now gonna take a int pointer, which is basically an address. And I'm gonna allocate Marshall dot allocate, let's say a gigabyte of data, because why not? 1024, that's a kilobyte by 1024, a megabyte. No, actually not a megabyte, but a megabyte. I think that's the correct term. And a 24 gigabyte. Cool. And well, eventually I now need to also get rid of this again with Marshall.free. Because, yeah, so this is unmanaged resources, so the GC doesn't know about it. Actually, let's give it a try what's happening. What if I'm not I'm disposing any of that? So let's check if we now create a derivative. Maybe in that loop. Let's use that loop, and we're gonna using var derivative, new derivative. I'll provide a constructor for simplicity that doesn't take a time span, which does time span dot 0 or infinite.
Ooh.
Is there time span dot infinite? No, there isn't. 0. And then calls into this. Oops, I can't type anymore. Cool. And so we don't need that. Then also dispose it, but in my dispose, okay, well, I'm not doing the dispose now, just to show what's going to happen, because we allocate now some unmanaged resources, so the GC is not aware of this memory. And I think we have a timer of every second. Oh, why is it stopped? Oh, application shutting down. Are we doing something wrong?
Yep.
Out of range. Okay. Time span max value, it's invalid.
Oops.
This is actually showing. I'm giving.
But time span 0.
Yeah. I should. I do the time span from seconds here as a default. Never mind. Okay. This actually leads to another problem of dispose, but yeah, or potential problem. So now every second we're gonna allocate a gigabyte. Oops. And well, we do call dispose, but since this is unmanaged memory, the GC doesn't know about it. And well, dispose by itself, it's just a method.
Yeah.
The dispose itself doesn't have anything to do with memory management or with potential. We now have a memory leak, and it doesn't have to do with any memory leak directly. Well, indirectly, it's a dispose pattern, and if you implement it, is how you deterministically clean up resources. But yeah, in our case, we were gonna eventually run out of memory.
Yep.
I don't want to run out of memory because live streaming. I don't want to ruin everything.
But
I
have
definitely now have to. Excuse me. Yeah.
Yeah. So, like as you said, dispose is just a method. So you could just, as you said, if you just have the method, you don't put anything in it. So it's a no-op method. Again, the compiler wouldn't complain, and you might actually. Yeah, and you'd think you're disposing something, but you're actually not. So okay, so this is a potential something to remember.
It's the implementation. It's the implementation detail of dispose that is now doing disposing of. You need to differentiate between disposing of managed resources and unmanaged resource. In our resource, you are disposing of a managed resource because this periodic timer that we are using, where is it? Periodic timer, there it is. That's a managed resource that will not do that doesn't do anything unknown to the GC. So even if we don't call dispose, everything should be cleaned up accordingly. It's just, in this case, calling dispose is to cleaning the resources up deterministically. The thing about deterministically is, well, we know exactly when dispose is called, after in the try finally of the using that is generated. So that's deterministic. We come to the indeterministic disposal later on. But also what you have is a managed resource. That's a managed resource. So if you wouldn't clean that up, you wouldn't leak any memory. Well, you wouldn't deterministically free up all of the memory that is used as soon as possible. But you wouldn't leak any memory because the GC is aware of all of that. It's all managed. So eventually, whenever the GC comes around and does a garbage collection, that is the indeterministic cleanup. Now we'll understand that eventually nothing is referencing to our resource anymore. Nothing is referencing this timer anymore. So this can be all cleaned up and reclaimed. But that's the indeterministic thing. When we call dispose and actually actively call dispose, that's the deterministic fashion of cleaning up. But since you have a managed resource, all is cool, we will not leak memory. It's just freeing up memory as soon as possible to keep our process, to keep the memory pressure on our application as small as possible and be good friends with the GC.
Yeah, exactly. So basically what you're saying is like if you're working with managed resources and you have a no-up dispose method, it's bad, but it's not the end of the world. Whereas if you're working with unmanaged resources and the GC, as you've done before, the GC is not aware of it, so it doesn't know what's going on there. So I also was wondering, because you're just allocating memory, and I just remember also from our talks that when you're working with like unmanaged resources, you have this like fixed keyword. So, but we're not really.
In this case, we don't need fixed because the GC is not aware of this memory. The GC is the fixed keyword. We need the fixed keyword then when we get a pointer or an address to a managed resource, because the GC is aware. What the example that we had is basically casting a string casting a string to a char pointer, where now this char pointer is pointing to the beginning of the string. But if this char pointer now is an address 0x something, string is a managed resource. The GC is aware of this resource, so the GC is technically aware. Well, strings get potentially interned, so they may not necessarily be moved around, but technically with any managed resource, the GC is free to move that resource around. Because if we have, like in our memory allocation, we have a lot of holes, fragmentation, what the GC can do is move stuff around to remove I'm not sure if this drawing makes any sense, but remove the holes and we reduce fragmentation so that we get larger blocks of memory free to allocate later on. So the GC is free to move in a compacting phase, move memory around, which means if now the string that we have here is potentially now at a different location, now this address is invalid or pointing to something that is now something else or to some memory that isn't active. So for that, if we cast a managed resource to a address, for example, to a pointer or to an int, to the int PTR type or whatever, then we need the fixed keyword in order to pin that memory, to pin that string, telling the GC, hey, we have some code that takes an address to this memory location. If you move that around, this address will be invalid. So please don't move it around. And at the end of the fixed, we will then unpin. It's like really pinning. We're like, okay, can I draw? It's like putting a pattern. Pinning it. It's also a pattern. Very good. And if it's pinned, the GC can't move it around. You have to pin something to the wall, but without the pin, the GC is free to move it around. So after the fixed, we unpin it. So the GC is now telling the GC, hey, we no longer have any address that is depending on it. Now you can move it around again. But since this Marshall alloc is entirely unmanaged, the GC doesn't know about this. The GC will not change. GC doesn't know about this memory. That's just
secret. Keeping secrets from the GC. Okay.
Exactly. And now we'll do since we actually do have in our example here, we do use a using. So at the end of this while block, we will dispose. So we should now no longer grow infinitely, but call this dispose every second and keep a sane memory profile. It's too fast, actually. Is it too fast? Because we call it and immediately dispose it, so it doesn't really show. Maybe we increase our timer from 1 second to 5 seconds.
Oof.
To see in the memory profiler some things going up. So every 5 seconds, we should allocate
5.
a.
Nope.
No. What am I doing wrong? Doing something wrong, aren't I? So we call on you. Is this even called? Oh, yeah. No, we still because we are here, and then we immediately dispose of it. So how do we? Because we have here the while. How do we? Okay. Still after 1 second here.
Oops.
But I will artificially do an await task dot delay 5 seconds here or 4 seconds here. So that we have between the creation of the resource or the allocation and the dispose at the end of this block. So we call a constructor, which is allocating unmanaged memory, a gigabyte of it, and then after the 4 seconds, reaching the end of this method and then calling the dispose. Now we should see. Some. Yeah. So we now allocate a gigabyte of memory.
Yep.
Then after 5 seconds, we should allocate. Yeah, we don't, because we dispose of it. So we actually don't see it. We just because what's the word? The sampling of this memory profiler that we have is every second. So we don't even see that we actually deallocate a gigabyte and then immediately allocate another gigabyte. But we now don't grow indefinitely because we now actually dispose this unmanaged resource properly.
Okay, gotcha. So actually we saw it even before we had this task delay, where we just had it a little less memory allocated, but it wouldn't really grow or shrink. So
okay. The thing is now, dispose is just a method.
Yeah.
What if I'm not calling it? What if I make a developer mistake and not calling the dispose? And I guess this leads now. What are we breaking now? Hello, Jason. So good of you to stop by. So we are now allocating every 5 seconds a gigabyte of unmanaged memory that the GC is not aware, and then we are not calling dispose, which is now where. So we are now back in the. Although we implemented dispose correctly, but dispose is just a method. We're just not calling it. So we now have 5 seconds grow until we'll run out of memory and streaming will get sluggish. But yeah, let's stop that. The thing is, in order to when you have unmanaged resources, then it's usually also good practice to implement a finalizer. That's a opposite of a constructor. That's a destructor. You need this very, very rarely. But in this contrived example, we're actually going to make use of it. And I totally forgot how to do a tilde. There it is. Because I'm now also using Mac. On a Mac, everything's different.
But you knew the word. I wouldn't even know the word. I'd just call it. I don't know what I would call it. I'd just make a wave with my arms and hope for the best.
Where we could do this now in the derivative in this finalizer. The thing is, when we have a finalizer on our object, when this method when this instance goes out of scope, because that's a class, the GC is aware of it. The GC is not aware of the gigabyte of memory that is allocated in an unmanaged fashion, but the GC is aware of this derivative. And whenever the GC now comes along and cleans up this object, it now sees that, okay, this has a finalizer, And I'm not sure if I'm doing the events here correctly, but then enqueues this object in a so-called finalizer queue, because there is a finalizer and we have a finalizer queue of objects that then gets called. But since it's called by the GC, we are in indeterministic land. So whenever there is something with the dispose method, because our using declaration is calling .dispose, or we can call .dispose in our dispose as well, that's deterministic. But when the GC is involved, then that's indeterministic. But still, although I forgot to call dispose, I should not leak memory too heavily, because every time the GC now comes along, this finalizer should be called. I hope. I may. Let's see.
Let's see. The pyramid keeps growing.
But that's the thing is, it's indeterministic. So what we could do is make it a bit more deterministic and call GC ourselves gc.collect. Kind of invoke. Yeah, you should never do this, but just to make it in this demo now a bit more deterministic, we shouldn't grow indefinitely now. I hope, unless I made a mistake. And yeah, we now kind of keep at this 2 GB sphere because our finalizer is apparently called. Let's actually confirm that by also attaching a debugger and see this method be called eventually. But yeah, we now call gc.collect, but it's, yeah, we shouldn't do that. So that's definitely now the indeterministic cleanup. But it's a bit of a fallback when when the developer, I just forgot to call dispose. Well, we haven't enabled all the analyzers. If we were, I think, is this analysis mode all? I think, not entirely certain. We should actually get a warning. Yeah, we now get a lot of warnings, but we get a warning here. Hey, we're not calling dispose. Before this reference goes out of scope, we're not calling dispose. So yeah, we also get warnings about configure await. So maybe let's keep the CA. Yeah, so that's C8000. I'll just disable the analysis mode again. I think the default is default, if I recall correctly. But yeah, so usually you have analyzers for that help you guard against forgetting calling this method. And yes, indeed. So that's an example of always enable all the analyzers, and maybe even sometimes warnings as errors so that you don't make the mistake.
Yeah.
But if we were making the mistake, now we do have this indeterministic fallback of calling this finalizer. The thing is about finalizers, yeah, this is indeterministic, so we're not cleaning up memory as quickly as possible. So our app will not be doing the best, but we do have a fallback in place. The thing is now, how do we properly, since we do have a bit of an inheritance structure with your type and my type, how do we now, coming back to the dispose pattern, implement this in a sane fashion? Because you have here's your type. It's your type, your base type. It's unsealed. So you actually don't know who is inheriting from this type. You don't know who will be calling this dispose. And there is some intricacies to that, and this is how to give some rules and guidelines of how types are supposed to, especially if they are non-sealed, how they're supposed to implement this dispose method. I'm not sure how to start at the sentence, but yeah, in order to bring this in some shape, there are these guidelines. And the guideline is, don't make the dispose method that you implement from the iDispose method virtual. So make this non-virtual. Just non-virtual, non-abstract.
Okay.
So there is
but now
virtual
something
call.
else.
Yes, exactly.
Broke it.
well, my type will be broken because I can't override dispose. So
Yeah.
you will need to implement some extension point for the dispose, which is now a method called dispose. Now you actually do create a virtual method. You call this also dispose, but give it a Boolean parameter.
Oops. Virtual code completion.
And this one is virtual, yeah. So it's also virtual. So you also call it dispose.
It's so difficult to actually type things. And you wanted a bool.
Yes. And this will be called disposing.
Disposing. All right.
We will figure out what this disposing means. In the dispose method, now you will do two things. You will be calling. So first of all, you will be moving your cleanup, your dispose, into this disposing method.
Yep. Easy.
So we now need to call this disposing method from the dispose method from the interface. So let's call into this dispose method.
What? Sorry.
So we need to from the dispose method that comes from the interface, we call into the new disposing method. But we basically get rid of this timer. This is moved.
Oh, yes. Okay. Okay.
Basically,
I see.
Basically, just moved our deterministic disposal into the disposal.
How do I get there? Oh, reset dot no. Do I just have? How do I get to that? Just dispose.
Because it's also an instance method and it takes this argument. The question is, what do you call it with? You call it with true. This true means basically from deterministic, or in other words, from, if you call it from dispose, or to be very particular, from the disposable.dispose. So this dispose method is called from this bool dispose method is called from the parameterless dispose method. The parameterless dispose method, that's a deterministic disposal, the deterministic cleanup. So we are on deterministic land, so this will be get a true.
Okay.
Now, what I'll be doing on my end, because your type now is fine again, because you have your dispose, and your dispose calls into this virtual dispose, and you will be disposing your timer. So you're all good. Now, and you also granted me an extension point, the virtual dispose, for me to do my own disposal in my unmanaged resource. Maybe I shouldn't call this derivative, but unmanaged resource. But yeah. And there we go. Now this derivative, I can now override, well, not the dispose, but the bool disposing method. The thing is now, I will be moving this into there. It should only be here. And from the finalizer, just as you called from the dispose method, dispose with true, I'll be calling dispose with false, because false means indeterministic from finalizer Q. And now in the dispose method, so when disposing is true, we know we have been called from the deterministic in a deterministic fashion. So we are using declaration or by calling .dispose. If this disposing it false, we know we come from an undeterministic fashion, so the GC invoked us.
Okay.
When the GC has invoked us, we don't need to deal with any managed resources anymore, because the GC is aware of managed resources. There is no need to clean up managed resources. They may be gone already. So no need to deal with managed resources. Actually, this is why I also bring now back this file stream. So I also have a file stream. Let's actually initialize this. This kind of will not work because this some location won't work, but yeah, just to point out the example. And the thing is now, I now basically need to differentiate between, is it called in a deterministic or in an indeterministic fashion? If it's called in a deterministic fashion, I clean up everything, both managed and unmanaged. If it's called in an indeterministic fashion, so from the finalizer queue, I only clean up the the unmanaged code or the unmanaged resources, because the managed resources may have already been gone, because we are now in GC cleanup world, and the GC is aware of managed resources and has cleaned them up potentially already in an indeterministic fashion, but they may be gone already. We only need to clean up the stuff that the GC is not aware of. So if disposing is false, get rid of this. Or in other words, we say only if disposing is true, we call the deterministic dispose, because if disposing is true, that means we come from the dispose method, no GC involved, with just the language, or we call .dispose. We're in deterministic land, clean up everything. That means the managed resources and the unmanaged resources. But if we come from an indeterministic land, managed resources may already be gone. So don't touch managed resources if disposing is false, because we may come here from this finalizer. But the unmanaged resource, well, the GC is not aware of unmanaged resources, so still clean them up. And this will now, well, we will crash here, but we will just come to another intricacy of the dispose pattern. We will now, even if we don't call dispose, we will eventually clean up this unmanaged resources, because I have a finalizer here, and the finalizer is calling dispose false. The thing is now, what if we do, if I now bring back the using, in the usage, I bring back the using to get to fix CA to what was it, 2000?
Yep. Something like that.
Now dispose is called, let's get rid of this GC connect as well. Now dispose is called at the end, invoking the base dispose, which is now calling into dispose with true. So what I definitely have to do is also call the base dispose, base.disposing, and forwarding this dispose, because otherwise I kind of would override your disposal. Now, what we currently do is deterministic disposal. We call at the end of this block .dispose.
Yep.
So .dispose is called with true. Since this method is virtual, we are actually at runtime not our resources, but the derivative. So we now call into this method. We are in managed disposal land because disposing is true. Therefore, we get rid of both managed and unmanaged resources. Then we call the base disposal, which is invoking now your disposal. And so the only thing that you need to change is to do this timer.dispose only if we are invoked from the deterministic fashion. So if we come from the dispose where disposing is true.
Like that.
Because this is when we clean up managed resources. Your timer, that's a managed resource.
Yep.
You don't have any unmanaged resources. And if the user would forget to call dispose, eventually the finalizer will be called, because we never called this dispose. Eventually the finalizer will be called, calling dispose with false. Now seeing, okay, we have a virtual method here, so we actually call in this dispose with false.
Nice.
We don't need to kill unmanaged managed resources because we came from the GC. Those unmanaged resources are gone already. Those managed resources are gone already, but definitely kill the unmanaged resource. Always kill the unmanaged resource. Then we call into the base dispose. Also with disposing false, well, managed resources don't need to be disposed, so all is good. The thing is now, what if we actually do it correctly? We do call the using correctly. Now what happens is dispose will be called deterministically.
Yep.
Meaning we clean up everything, both managed and unmanaged resources.
Yep.
But in this derivative, we also register a finalizer. So then afterwards, we also call dispose false, which is we kind of dispose again. We already invoked dispose with true, cleaning up both managed and unmanaged resources, which means also the unmanaged resource is gone. I'm kind of now disposing again. Well, there is a guideline to dispose. You should be able dispose should be able to be called multiple times without throwing errors.
Okay.
But it's unnecessary. We call dispose again, although we know if we come for this method, yes. But we don't have an error. Well, actually, I'm not sure if this is super fine because we kind of free something that has already been freed in unmanaged land or in C++, C++. I think there is something with double free. I'm not sure if double free is safe or not. I'm not certain. I don't think so because technically this address could be pointing to something else, could be reused.
Yeah.
And now we kill somebody else's resource. So I don't think free twice is safe.
Shenanigan, but
this already is a problem. We need to ensure only once, but we'll come back to that. We make this more safe. That's a keyword. But also now in our fashion, we don't need to call the finalizer. So there is now a way, if we call dispose deterministically, we don't need the indeterministic finalizer. We can get rid of that. We can actually unregister this finalizer. There is a method on .gc that does that. Maybe we can find it together.
On GC?
So in the dispose, in the parameterless dispose,
there we are. Oopsie.
You'll explore the GC because now what we want to do is to remove the finalizer.
I didn't write that.
From the queue. And that's called suppressing. So maybe we find a method that...
Yep.
Exactly.
Code completion. It sometimes doesn't work as well with like code with me, but sometimes it hits the spot.
Now this, if we call the deterministic dispose, which ensures that both the managed and unmanaged resources are gone, because we call it with true, everything is gone, we don't need to call this backup finalizer in case we forgot to call the dispose, because we know dispose was called.
Yeah.
So we can also suppress the finalizer, giving better performance, because everything you have in the finalizer queue, well, the GC eventually needs to call. And well, work that the GC doesn't have to do is just better because we tell the GC, you know what, don't care about this object. We already got rid of all the managed and unmanaged resources. There is no need to call the finalizer to enqueue. Once this object goes out of scope, there is no need to put the finalizer on the finalizer queue because everything is gone already. So we do a bit of a performance improvement there. The thing is now, you need to implement that. Although your resource doesn't have any unmanaged resources, nor does it has a finalizer. But since the type is non-sealed, there could be derivatives of it, which introduce as a finalizer. So although your base type, your non-sealed base type doesn't have a finalizer, the pattern is to call GC suppress in the parameterless dispose method from the deterministic flow to, if there is a finalizer on a derivative, to suppress this finalizer. Now, if there wasn't a finalizer, this would be no op, nothing bad would happen. But in order to fulfill this dispose pattern, this is what we do. And so whenever you have, this is why I like to make my type sealed, because then I need to think about this. If a type is sealed, the dispose pattern is super easy. I know there is no finalizer, so I don't need a finalizer. I know nothing can be overloaded, and I know it's always deterministic. So this is how we actually started with. Super simple. That's the dispose, and the dispose pattern correctly implemented. But if we could inherit from it, then you don't know what the inheritor. We actually get a warning if it's sealed. Then we get a warning here. Hey, you suppress the finalizer, but this type doesn't have a destructor. The compiler knows this type is sealed. We don't have a destructor, a finalizer here. there can't be any inheritor that has a finalizer, so this is always no op.
Yep.
If it's not sealed, no, they're just maybe, not necessarily, but they're maybe. And I think this is, for example, with Stream. Stream itself doesn't have a finalizer, but I think the derived file stream has. I think, I'm not entirely certain, but something like that. And this is how this dispose pattern. So whenever you have a base type, when you're inheriting from a type that is implementing the iDisposable interface, then usually you have this bool disposing method, not this one virtual, but this one. And you don't need to think about finalizers. You can add your finalizer in your inherited type, but you don't necessarily have to. Now, we get a warning here because there is one thing left. This dispose method should actually be made protected.
Ah.
Because what I could do now from the outside is I could call dot dispose with true. I could call this overload. I could not lie and say false here. So I'm calling dispose, but saying disposing is false, which means indeterministic. But I'm calling dispose here. This is very deterministic, so I could lie. In order to prevent this, we make this bool disposing method protected. So from the outside, it cannot be called. So yeah, I of course need to make this protected as well. Protected. Now from the outside, we can't call this. We can only call the one without the overload, which is now calling the disposing with a true because it's deterministic, because we called dot dispose.
Nice.
And that's the first part of the pattern. Now, I mentioned a bit of a problem here that we do kind of do a bit of a double free.
Yeah. Sounds like some handy method or something on the GC. No, probably not, because it doesn't know about this part of memory. Wait, I want to jump to you. Where are you? Here you are. Okay.
We'll come back to that. I just see that Thorsten Training is back.
Hello! Welcome back. Thanks so much for joining. Long time. Oh my goodness.
I want to get to one thing. What if I don't do this disposing true? There is actually a bit of a problem. So it's important to not touch managed resources in dispose from an indeterministic fashion. Because I mentioned, I actually have a problem here. What will happen here, this constructor will throw an exception because some file location will not be found. Now we're gonna see an interest. I think I need to do, I'm not sure if this is all try caught as expected. But if it works as I would hope, we would eventually cause, maybe I need to bring back a GC dispose. Let's call GC collect again, because I'm hoping to find an interesting exception that we would not expect. I hope. Let's see if this works as expected.
We
Unless it may not. Yeah.
Nope.
Nope. Because I was hoping.
So it does find some location.
To run. Did I do debugging?
No.
Because actually,
I don't think so.
Well, this should quite throw, right? Does this not throw? Oh, because I do, yeah, because I think I do an append. So what I should do is a read, file mode, just open. Because I think I created a file. Let's go. Can we go into the solution view? I don't see.
There's
usually. Am I zoomed in too heavily? Zoom. There is usually a. There it is.
Oh.
File view, and bin debug. Now I guess we have this file somewhere created, I suppose. Or is it some file? Is it not? Well, it depends on what. There it is, some location. So
Some
I'll get rid of
location.
that.
Lovely.
Now this shouldn't happen anymore. If we run that again.
Now there's something.
Now we get the. Oh yeah, but this crashes the application. Okay, let's do. How can we reproduce this problem? It's me again. So, because we create this derivative. This may actually throw. So what if we do a? Let's do a try catch around that, and if we catch an exception, let's just write that exception. So I'm basically swallowing the failure here. And I'm hoping that after some time, if it works as expected. So we got, okay, that's what we see is, well, we got this file not found exception. File not found exception. At some point, the GC comes along.
Yay!
We get a null reference exception. And from the call stack, we see that this was invoked from a finalizer.
Ha!
But if we go into, we see here, this is our derivative type, the finalize method. So this is actually what happens in IL when you have this this tilde. You get the final. This is why it's called, by the destructor. I think in C# language it's called destructor, but in IL then it's a finalizer, or in .NET it's a finalizer. We for some reason get a null reference exception, but we don't have any nullable warnings, do we? Let's ensure that we got nullable enable. Well, it's grayed out, but we don't have any nullable warning, but we actually get here a null reference exception. Can you imagine how looking at, well, the constructor and the disposing here, and also maybe we put them kind of in order. First, let's have the constructor, then let's have the destructor, and then let's have the dispose method. Can you imagine what the flow is, why this file here is, and under which case this file here is null?
In which case the file is null. We are, in case we call dispose in a deterministic fashion, because we're in the overload now with the bool. So if we call it deterministically, we actually clean up all managed resources, including the file?
Not quite. Dispose will not be called in a deterministic fashion, because this constructor here will throw. Actually, if we take a peek at the IL, because, oh no, that's async. Okay, this will be quite difficult to read. But so we have a using here, which basically gets translated into a try catch here, try finally here. So we have to finally dispose here. But, well, this constructor throws. So there is no dispose to be called, because if you, maybe let's go into.
But we still call finally, right?
We call, in this case,
finally.
No.
Oh,
no.
Okay. Sorry. Gotcha.
What this translates to, maybe let's write it out, is yes, it's a try finally. But what it translates to is to basically creating the object outside of the try. Well, in our case, we then had an empty try, and then in the finally calling the dispose. So this is what it gets translated to. So in our case, no, the deterministic dispose will not be called. I'm now reverting this back to what it originally was to make that a little bit. But this is basically, since we don't have any code afterwards, if we had some code there, then this would be in the try block. So this would be part of the try block, but this is outside of the try block. So no, the deterministic one is not called. So how do we end up in dispose? If it's not from the deterministic one, it's from the
indeterministic one.
Because although this constructor throws, we still have a finalizer.
Yep.
Now, This we throw here, file not found, meaning that this file will be null. Well, we don't have any nullable analysis guarding there because, well, we assign it here because the null analysis doesn't know that this constructor may throw.
Okay.
But in case that this constructor throws, file will be null. Now, this won't be a problem in a deterministic fashion because dispose won't be called because there is no instance. But we have a finalizer. And eventually, this is why we got the file not found a couple of times, and then indeterministically we got the null reference exception because this one is called. We call into disposing. We now try to call dispose from a null instance, which now leads to the null reference exception here. And if we question a finalizer, application goes boom. Because we can't catch that. I'm not sure if you can attach some handler, but I don't think so. So yeah, this is a bit of a latent bug. If our constructor may not complete, we have a finalizer, and we are null here.
Oops.
Again, this is why in the indeterministic fashion, when it comes to managed resources, don't touch managed resources when you come from the indeterministic fashion. We now fixed this NRE. Now we could just, but I'm not doing any null check. I'm still not doing any null check. Well, we could technically have done a null check here and solve the problem this way, but even without a null check, now this will run forever. We will always get, continuously will get a file not found exception, but we're still running. We won't get a null reference exception because we now call dispose will still be called. Maybe I actually do a breakpoint to show that, but when it comes from the intervenistic fashion, we don't care about any unmanaged resources. So actually there it is. Disposing is false. We come from the destructor. I guess we also see it in the call stack. We come from the finalizer. But since we are false, we're not touching any unmanaged resource because this file is indeed, although it's not annotated as null, it's null.
It is null, yeah.
No need to do a null check because we don't touch managed resources when we come from the indeterministic fashion. And dispose, the deterministic dispose can only be called when the constructor has completed and file indeed will be not null. So all is good.
Yeah, well, all is well, but we're still calling base.dispose right at the end. So we have improvements to make.
Well, no, that's cool. That's cool, no, because we now call into this dispose, and you also do this disposing check here. So even, I'm not sure, but because the parent
we're not doing anything there. Yeah.
If timer was null, let's actually do a breakpoint.
But because we passed in the bool disposing false, so we should skip this as well.
And timer. Okay, well, your constructor passed, so. We do actually have an instance here, but we come from the indeterministic fashion. We shouldn't touch any managed resources anymore. So we skip over it and all is good.
Okay, fair enough. But how do we only call the Marshall thingy once?
Yes. Well, what we could do is ensure that this is called, only once. So there is like this pattern of, we could check if this address is int pt, if this address is an int ptr.0.
Yeah.
Fun fact: do you know the size of an int pointer? How many bytes does this int pointer have?
An integer has 4 bytes, right? So maybe 4.
But this is not an integer; it's an int pointer.
Okay.
That depends on the bitness. In this case, it would actually be 8 bytes because I'm on a 64-bit process. If it was in a 32-bit process, you would be correct. That's actually the trick about int ptr, or also in newer language versions, we can also use n-int. That's a native integer. That means it depends on the target platform and the process, whether it's for 32-bit or 8 for 64-bit. Anyway, I digress. So we could say if this int pointer is 0, if this int pointer is not 0,
then we get rid of it.
And then set this pointer to 0.
Nice.
So that means I need to make this not read-only because it's mutable. But now we could have a bit of a race condition. What if dispose, for some reason, is called, because we later on talk about async disposal as well, what if this is called concurrently? What if
we can lock it?
Yes, we could lock it and solve the problem. But locking is kind of, whenever you lock, you're blocking. And that's not great for performance. Yes, we would solve the problem, but not in a performance kind of fashion. So this is where you could do atomic operations. There is this interlocked type. You can do something like interlock exchanged. I always need to look up the documentation because I always mix it up. So this is atomic, thread safe. We pass in, okay, I need to take a peek at the documentation. So this one.
Yep.
Where is it? This is always confusing. So we take in a position. You see, we pass this by ref.
Yep.
So we're not passing although that's we're here on the int version. Where's the int ptr version? There it is. So int ptr is a struct, but we call by ref. So we're calling a reference to this value type.
Yep.
That's the location.
Yep.
And the value to which you want to set it to. But it returns the original. So what it was before it was set to that new value. So what we can do here is basically do something like that. If we pass this reference, set it to 0, and if it before was not 0.
Yeah.
Because it returns what was before. And if it before was not a 0 pointer, then we enter this, and this is atomic, so we only entered once. And the next time we come along, address will be 0. We set it again to 0, but it was previously 0, so this check will be false, and we are not freeing again.
Yep.
So we also don't need this either. We now have it guarded like that. But that's kind of
pretty cool.
Yes, but it's easy to get wrong. I had to look up documentation. Well, actually knew this because I just actually we did this at my company just 2 weeks ago. If I wouldn't have done it 2 weeks ago, I would have not known I wouldn't be able to read this and explain this and understand it. And I would say, what is this?
Fair enough.
So what you actually should do, the comment I had earlier was save. If I was able to spell it
And
correctly.
you said it's a keyword, so...
Not really a keyword, but it's a trigger word. So what I'm going to do now is what we should this be a struct? No, I should think a class. So whenever you deal with pointers to make them, because this is kind of the expert mode. But we could make it inherently safe by deriving our, how do we call this? Maybe let's call this Marshall handle, Marshall safe handle. We can derive a new type from, there's a type called safe handle. And safe handle safe handle is taking care, it does the dispose pattern correctly, and it takes care of the lifetime of this int pointer or of this resource. And there is a derived type that's called safe handle 0 or -1 is invalid. That's kind of a bit of a mouthful, but this is exactly what we need. If the handle is 0 or -1, well, in our case, if it's 0, then it's invalid, because this is basically what we did. We set it to 0 to make it invalid. So we could now basically use this one. Need the correct point, generate a constructor. I think we also need to implement a missing member to release the handle. And I think that that the implementation of the safe handle is taking care of all of this thread safetyness and such. And this release handle is only called, they do this interlocked exchange and all of that fashion. And I think there should be a finalizer somewhere. Is there? I can't write the tilde again. Tilde. There we go. So they do all of that correctly, and this safe handle 0 or -1 actually says, well, if this handle is 0 or -1, then it's invalid.
Yeah.
So all then we can do, basically, this is now our Marshall safe handle, where with the Boolean, we say, do we own the handle? Or is it somebody else owning this handle and should be releasing the handle? I think that's here. Let's see. In our case, we are owning the handle, or the instance of this type is owning the handle. So we could now, I'm not sure if I'm getting this 100% right. This is a bit advanced. I may be doing an error here, but what I would now do is basically move our allocation in here. No, wait a minute. This is not, there must be a handle somewhere. How can we actually, I think I need to go cheating, because this handle, how do we set this handle? I need to set this handle somehow. Save handle. Oh yeah, we call invalid handle value. Wait a minute, it's the invalid handle value. Okay, I need to look at documentation.
See, like the advanced mode, you had to look at documentation, but with this
well,
one as
because I haven't built it before. We will, in our code base, we will refactor the code that we currently have to the safe handle. We have a task for that, and then I can do it.
Do we?
I should be. So no, like in the what I was mentioning at my workplace, we do have some native interop, and we are using.
I thought we had a task on our work.
No.
I was like, wow, I completely forgot about that. But yeah.
Let's see. So we basically, oh yeah, we do have the handle, and actually not. How do we get the handle? Is this, I need to take a look. I may have misunderstood something there. Take a look at the handle, temp handle. Okay, I should have done more research. I totally forgot about this. I just thought about it just before we started, that this is how you should do it, because it's taking care of all of this interlocked exchange and stuff. Okay, I'll not be able to reproduce this now, but and we're already over time, so
as per usual. I mean, it wouldn't be us if it wasn't. But we can just stay in expert mode and
but this is something that
be happy with that
I would then, because this is actually the code that we have in our repository now, also at my workplace.
Yeah,
where we do something with native interop. So I think that, well, it's open source. We could look at it, but. Yeah, so this is now kind of but I think this could be replaced with a safe handle, and then it's even safer. But yeah, that's basically the dispose pattern, and the reason why this disposing true kind of is a thing, because if your type is not sealed, you don't know who is inheriting it, and you don't know if this inheritor now has unmanaged resources and may be requiring as a fallback, if something goes wrong or the developer forgets, even though there is analyzers, to call the deterministic dispose, to do an deterministic dispose, to definitely clean up those unmanaged resources, because in our case, we would go out of memory quite quickly, every 5 seconds, a gigabyte. So yeah, that's the synchronous dispose pattern. But of course, there's also the asynchronous dispose pattern. Now, would you mind, usually, I think that's part of the guideline, usually when you offer async, you don't you usually don't just offer asynchronous disposal. If you offer asynchronous disposal, you also offer synchronous disposal. So we leave all the code that is as is, and now we're going to extend this to also support asynchronous disposal. So you wouldn't mind getting started with asynchronous disposal.
But I need to leave the code as is. Could I?
I would leave the code as is because
I trust you. But
because if we technically could only support asynchronous disposal, but I think it's
because dispose async is a pattern for every kind of type. Is that what you're saying? So we don't need to add the interface?
Because I think if we have actually yes, we do the interface, but I think it's part of the pattern to, if you have asynchronous disposal, to also offer synchronous disposal.
Okay. Sorry. So I can do this.
For the actually, no, we should keep the iDisposable interface, but add iAsync on top.
Got it. Okay. Well, I'm so glad you're so patient with me, because I think every viewer already got you the first time, and I was like, what? Where? Here? Okay.
Now, well, again, if this was a sealed type, super easy. Where is this? I think that's from some YouTube channel that I like to watch. Super easy, barely an inconvenience. We would just implement this method and basically be done with it.
Yeah.
But since we are open, there is of course intricacies. So
lovely.
Yeah, I guess we already implemented the dispose async. So actually, now we need to have an async. Is the periodic timer async disposable? No, it's not. Maybe you now also get a stream. I'm just gonna add or maybe you get is the HTTP client? Does the HTTP client have async disposal? I believe so. Message invoker? No, it only has synchronous disposal. But I believe the stream has asynchronous disposal. Yes. So you now also get a stream.
Woohoo! My own stream.
Your stream. And let's just initialize it to something. Let's do a memory stream.
Yep.
And cool. Okay. But yeah, I guess if we were to turn on, I don't see this. Let's use purge. CA, let's do all. CA 2000 now will complain that we have, because an applications API isn't typically referred from the outside assembly, you can make it internal. Yes, that is correct. But I was hoping, there it is. Our resource contains a field stream that is disposable, but it's never actually disposed. Change the dispose method on our resource to call dispose or dispose on this field. Close or dispose on this field. So yeah, let's now also, this is a managed resource. So let's dispose it in a managed fashion and fix CA 2213.
Yeah.
Now, still thinking about synchronous disposal, just to get this one right.
Yep. So, yeah. Stream. That's not it.
Yeah. Now, no. Let's come. Then we have one final closing point. Okay, cool. And now let's think about async disposal, because we noticed our stream can actually be disposed in an async fashion as well.
Okay.
I mean, but we are...
No.
So, well, actually...
Oops.
So what yes, because, well, the timer doesn't have an... The timer doesn't have
I didn't put it. That was the autocomplete, I swear.
Yeah. I mean, but
Stream.
That's also good. That we should also dispose the timer.
Oh. Okay.
But the timer doesn't have asynchronous disposal, but only synchronous one, but that's fine. Then we call it a synchronous version, because if we don't have the option, then we just call the synchronous version.
Okay.
And then the asynchronous one, yeah.
What was async? Easy. And
Now,
we need to return a value task.
yeah, well, so this dispose async, that's actually async, so that
Okay,
returns a value task, so we should have waited.
Woo! Oh. And can we also return it?
Well, we don't need to, because we now make this method async, and then all is good.
Okay.
I think the warning that we get is that it's complaining about configure await, but yeah, we'll not do. Well, technically, this is a library. No, actually, we are in an application, and we know this application doesn't have a synchronization context. So in this case, we don't need. We can suppress. We can no warn. CA 2000, is it 2007? I believe so. That depending on the synchronization context, but yeah, so that's cool. But it says, okay, there is something, C1816, that's about the dispose pattern. So we don't really have a pattern here, because again, what if a derived type, our resource, oops, sorry, let's jump to the derived type. The derived type also has a file stream, which could also be asynchronously disposed. So how do we now make the asynchronous disposal also extendable?
Virtual?
We could make this virtual, but that's not, I mean, we didn't do it like here. We didn't make the interfaces dispose method
You
virtual.
call a virtual overload.
Yes, but that's then slightly different. So yes, we do create a virtual. So we don't do a virtual overload, but we create a new method group that's now called dispose async core, which is now virtual. And similarly, it shouldn't be public, but just as we made the synchronous extension point for disposal protected, because again, this method should be able to be called from the outside, not this disposal as an implementation detail. And yeah, you're already.
I'm getting these down here, right? And here we just call. Async core. And then we also have to pass in a bool again?
No, there is no bool now. But this is now, the thing is now, dispose async core, when it comes to unmanaged resources, there is no asynchrony. So we don't, for the asynchronous version, we don't need this differentiation between do we come from the deterministic or from the undeterministic land. We basically, if we call dispose async core, that's about the deterministic fashion. So we know here we are in deterministic land.
Okay.
So what we basically can do is just call it. Well, we also need to await it, but yeah.
Oh, yeah. Oops. No. Yes.
But we still get a warning because it actually says so. Because what if now, actually, let's go to the example. We now have our using here. We now do await using on the derivative. So we no longer call dispose. So this method is out of the picture. We call this method. But we don't suppress the finalizer in case the deterministic dispose was called. So we basically have the same thing as like if here we call this extension point and then do GC suppress finalize this. And yeah, this is the same that we should do here. We call the extension point and then suppress finalize this.
Okay.
So all we need to do is suppress the finalizer. Yeah.
Yep.
And now I can go ahead and basically extend. Oops, I always do the wrong key because now override this isn't this the core. I need to think about the unmanaged resource because that's coming from the finalizer if it's not suppressed. So if we haven't cleaned up everything. So what I now need to do, this means this is basically the world of cleaning up everything. Deterministic fashion. So I'll be basically doing this and calling, we know we come from a deterministic fashion, file dot, I can now do with dispose async here as well. Make this async, and I do definitely need to call into the base. What's the matter here? I think just inconsistent order. And actually, now I need to go cheating because that's one point that I'm not sure if I wrap my head around it correctly just yet. But I just need to make sure. Actually, let's take a look at it together. Because now, how do we combine the asynchronous and the synchronous version? So if we have both, yes. So when we are sealed, super simple. Just call it a dispose. No extension point needed. If we are non-sealed, then we kind of need this thing. So as a disposable, we have the dispose async where we call into the core and do a suppress finalize this because we don't need any finalizer anymore. If the inheriting type may have a finalizer, we don't have one here, but we don't know at this point because it's not sealed. And then we just do the asynchronous disposal. Now, what they do here is, so I guess this is good enough for disposal. They're basically nulling it out because again, just as dispose should be able to be called multiple times without throwing, dispose async should be able to be called multiple times without throwing.
Yep.
And so also these from the managed resources should be fine to be called multiple times. So we don't need to think too much about like being super thread safe or atomic there. So I guess just nulling it out. And then the next time it's called, basically a bit of a performance optimization. Should it be called again? It's not null. We don't need to call it again. So I guess that's good enough for that. But what if we have both? So we now call, now I can connect because in the dispose async core, we know we are deterministic. So we clean up all, but only. We only do asynchronous disposal. So in our dispose async core, we only do async disposal. Whenever it comes to dispose async, well, there is a bit of a thing here because it checks, is this disposable resource, is it async disposable? If it is, then call dispose async. If it isn't, then the synchronous version. Then nulling everything out. But still, so we deal with the asynchronous disposal here, and so we deal with the disposing of all of the managed resources. But what about the unmanaged resources? This is why we still call the dispose, but with false. Well, I guess this is now a bit weird because dispose async is deterministic, but when we do false, it's the undeterministic thing. But this is where it gets a bit weird. But
because like opposite.
In the dispose async core, we only get rid of all the managed resources. How do we get rid of the unmanaged resources? By doing the same path as the indeterministic version will do, calling dispose with false, which only gets rid of the managed resources in order for us to get rid of everything. So let's implement just that. So in our case, let's take a peek at this type. So in the dispose async core, get rid of all of the resources, which we do. We dispose timer, we dispose timer async core. And then we need to call the can I think about it? The dispose with false here as well.
Okay. Oops.
So doing dispose false to get rid of the indeterministic resources as well, or of the unmanaged resources as well. Now, well, in our case here, we don't have any unmanaged resources. So this dispose is basically no op because we just got rid of the timer and the stream already. We just disposed it here. Because we ensured this dispose async core is killing all of the managed resources. When we call false, there shouldn't be any managed resources in the false path.
Yeah.
So that's good. And in the derivative, now basically doing the same thing. Actually, I made a mistake here, so that's wrong. Only disposing the synchronous. Oh, sorry, I'm always saying it wrong. The managed resources, difficult. So this core, dispose managed resources only. Because this is where we get, when this is called, we call async dispose core. This is overridden, so we call into the overridden version. We get rid of the managed resource in this type, which is only the file stream, because the file stream, well, we have here a managed resource and an unmanaged resource. So we kill, or we don't kill, but we dispose of the unmanaged resource in an async fashion. Then we call the base so that your disposal is called as well. And well, timer doesn't have an asynchronous disposal, so we do it synchronously, but the stream has an asynchronous disposal, so we do it asynchronously. Then we call dispose false so that we also get rid of the unmanaged resources, which is now calling what we had previously, this dispose. Sorry, not this dispose, but this dispose with false. So this is virtual. Now calling into this dispose. Disposing is false. So again, we don't need to get rid of the managed resource because we did the managed resource already in an asynchronous fashion. So no need to do this again in a synchronous fashion. But then we unconditionally clear the unmanaged resource because we come from dispose false. Then again, call into the base dispose, which is now calling your, your dispose. And again, same story. We already cleaned up all of the managed resources. You don't have any unmanaged resources, so this is false, nothing to do, basically no op. So all is cleaned up.
Wow. And well, that's quite a ping pong.
It is, yeah.
Yeah. Okay.
But we ensured that when we deterministically dispose or dispose async, dispose this object, we dispose synchronously or to some degree asynchronously, if possible, all of the managed resources, but also the unmanaged resources, because we come from a deterministic fashion, nothing should be used anymore, everything should be gone. Now, in an indeterministic fashion, we shouldn't deal with any unmanaged resources. The indeterministic fashion is a potential finalizer. The finalizer is now calling dispose false. When we come from an indeterministic fashion, there is nothing async involved because all of the async methods, so this dispose async core is only dealing with managed resources. So we don't need to think about that. We only need to kill unmanaged resources, which is the false from before, making sure that our unmanaged memory, that this 1 GB is cleaned up, but all of the managed resources are untouched because the GC may have cleaned them up already or will do so indeterministically soon-ish. Now, there is one comment left. This is also where a safe handle would help, because this is another thing to potentially do wrong. It's about the there's an object disposed exception. Although dispose, as of any dispose, either dispose or dispose async, should be able to be called multiple times without throwing.
Yeah.
After an object has been disposed, it shouldn't be used anymore. So actually, I can assume there is an analyzer for that. If we call, let's have our derivative here. Now let's write some, actually let's use the logger. Use. Now we say derivative, we use the object, but eventually we want to dispose it. We are in an async method, so we can either use dispose or dispose async. Let's do dispose async, which now gets rid of all the managed and unmanaged resources. But what if we still use it after we have disposed it? Let's call this wait for next tick async, perhaps, which is taking get a lot of warnings. I just want to make sure that we only get the one warning that we need. It actually doesn't produce a warning. Interesting. I was expecting a warning that we shouldn't use. Maybe that's another room for an analyzer. We shouldn't use a resource after it has been disposed. Well, when it has been indeterministically exposed, we can't use it anymore anyway because it's the finalizer called it or the GC called it via the finalizer. So that means it's out of scope. There is no reference to it, so we can't use it anyway. But if we dispose of it deterministically, either by calling dispose async explicitly or implicitly we are doing an await using.
Yeah.
Afterwards, we shouldn't use the object anymore because, well, we would actually now use this timer, but via dispose async and dispose async core, we already disposed of this timer. So
we would get this exception. No.
Yeah, we would now, actually this timer now should, I'm fairly certain that there is something implemented that this will do an
lock
object dispose.
Sorry.
They do, there's some lock synchronization. If you can write it lock free, that's usually better for performance, but sometimes you just need a lock. I'm wondering if they do, okay, they don't do an object disposed exception, but
yeah.
Okay. But what sometimes I think stream does that. So if we were using the stream after the object has been disposed, I don't know, let's say something read. What read will have, oh, that's abstract. But would we, oh, it doesn't have. Maybe the file stream does it. If we jump to the, I'm hoping somewhere to find an object disposed exception. Maybe in the derivative and in the file stream of it. So there is a helper called validate handle, which is called, maybe let's do a read here, derivative, file stream. So at some point, maybe we also have a method here, public void use or something, where we now say read. And read does validate read write args and does a strategy read. And yeah, I'm not sure if we can follow the call stack now, but eventually I'm fairly certain we will run into this object. There is something with the strategy and saying, well, if the strategy is closed, which I guess is true when it has been disposed, we throw an object disposed exception. And in some cases, we want to surface this in our type as well. So what you then see often is that you could do something like a private bool disposed boolean, which is of course false per default. It's not disposed yet, but if we dispose in either deterministically or undeterministically, meaning we definitely come by one way or another to the dispose, we could set dispose to true.
Okay.
And then in the method, which we are not supposed to use anymore, we could do an if disposed is true. So if this object has been disposed already, then throw a new object disposed exception. And I think there is an overload that takes a string, which is I think the object name. I guess usually you do this dot get type name. And this is so common that there is actually a helper method now in modern versions where you can say object disposed exception dot throw if, which takes the Boolean, the condition, if is true, we throw, and also the instance, where if we follow that call, we will do this get type full name. Okay, it's actually doing a get type full name. So what I should have done manually is not get type name, but get type full name. But we can simplify this by just calling throw if disposed, passing in this, which is just a one-liner, doing the same thing, which is now throwing after the object has been disposed, so that we indicate to the caller shouldn't use the object after disposal anymore. Well, it is safe to call dispose multiple times, but every other method or any other member now no longer may or may not, depending on the design of your type, may or may not be safe to use anymore. I mean, in particular, maybe with managed resources, I'm not sure if there could be too much trouble, but what about this address here? Mm-hmm. After we have disposed this unmanaged resource, well, we should definitely not access this anymore, because maybe we have a write method where we use this address. I'm wondering if I can get this right. Well, I think span should be able. We could have a span of bytes. We call this our memory, where we create a new span, just to use some span as well. Because I think there's an overload that takes a pointer and also a length, I would hope. And I guess this would be our length. Or is there not? I thought there was. Oh, there is only one that takes a void star. There is none that takes an int pointer. Now, I guess there is a way how to convert a int pointer to a void star, but I'm not sure. Pointers can only be used in an unsafe context. Unsafe?
Okay.
Okay. Now we need to enable unsafe context in the project. I think there is an allow unsafe. So you can only have an unsafe context if the project allows unsafe code blocks. But this still doesn't quite. Int pointer is not assignable to void star. Yeah. I guess there is a way how to do this, but I will not get this right anyway. But yeah, let's assume this kind of would work. We could now use this as a scratch buffer and write some bytes into this, and may also be reading some bytes from it. But after we have disposed the memory, well, we shouldn't access this pointer anymore. So here we definitely should have a object disposed exception dot throw if, and basically have the same thing. So after, that's the use method here. So after because this dispose is always called either via true or false. Set disposed here to true, and then throw if disposed and this instance to make sure that we definitely do not access some unmanaged resource after we have disposed it. Because, well, what if I'm actually not sure what happens. Well, we would be accessing some zero pointer. I'm not sure what kind of memory we would get, but it's definitely not deterministic or safe or anything. So yeah, we shouldn't. Or what if we wouldn't zero out this pointer, but leave it? Well, we free this resource, but then in the meantime, some other component may claim this memory for them, but we kind of still have a pointer to this memory, now doing some undefined behavior kind of a thing. So in this case, we should definitely throw with doing anything with managed resources.
All right.
And I believe this is all that is to say about the dispose pattern. Other than, I think this is one thing I would like to point out. I'm not sure if I understand that right, but maybe we can figure this out in 2 minutes.
Famous last words.
Famous last words. No, if we can't, then we will refer to the documentation. Because there are some,
Nice.
just get rid of it. There are some usage patterns. I have this odd déjà vu now. I have this oddest déjà vu. Have we been here before? I don't think so. There is this usage pattern of some how you do async disposal. So what you could do is, because depending on if you're writing a general purpose library, you should also use configure await. And if you have multiple resources, how to stack them? You would create a resource, then have an await using block, create another resource, have an await using block. You could also do them individually. If you kind of don't need them at the same point in time, you need resource 1 after usage dispose it, resource 2 after usage dispose it. In this block, we could use both the outer resource and the inner resource. It depends on what you need. We can also use the not the using statement, but using declarations, where this is basically the same as this one, because we do have an outer resource and an inner resource. And if we would take a look at how this is decompiled, we have, because if we have an await using, then it's until the end of the block. So this would be our outer resource, and this would be our inner resource.
Mm-hmm.
But it says that this is an unacceptable pattern.
Ooh, okay.
And I'm not entirely certain why this is. So I'd like to give that a try and see what the compiler makes out of it. Maybe let's do a public async task. Yeah, to work. Paste it in and replace this with our, let's do an our resource and a derivative. And our resource takes, it's just passing default. So because, in this case, why is this like creating the objects before we go into the usings? Because what we saw from the other examples, the creation and the using, they're always very close to each other, or like adjacent. They are like literally together, one way or another. But in this example, we would disjoint them. We would have the creation here, then we have another creation, and then we have the usings. Now, if this constructor would throw, nothing would be disposed, because we have the using blocks here. And basically, our resource here, actually, let's turn this around. Now here, we should have the memory leak again. Or do we? Because, no, actually, we do have the indeterministic clean up, I hope, but the deterministic version would be gone. We wouldn't call any dispose.
Are we in unmanaged land somewhere?
Well, this
our
derivative, yes, but we have the finalizer, so everything should be fine.
Yeah, so we couldn't have a memory leak.
We shouldn't have any memory leak, but we would clean up now. What we ensured previously is that when we do call dispose, that we actually clean up our resources in a deterministic fashion if dispose is called. But here we now actually have await using, but we wouldn't dispose. We wouldn't have the deterministic disposal because we create the object here, but have actually, I think, because I turned this around, I guess we should No, that's fine. We have the disposal down there, but if this one throws, we never call the deterministic disposal of this one. So we would be now relying of the finalizer we have. But this is coming into deterministic, so we definitely have more memory pressure because what we saw whenever the GC comes around, we could build up to 10 gigabytes of memory before the GC starts cleaning. I guess it very depends on the profile, and I guess there's also a difference when you do debug or release mode and stuff. But this would not be ideal. So I guess the takeaway there is always keep the usings or the async usings close to the, because what you can't do, I guess that's a bit of a weakness of the async disposal. When you have synchronous disposal, we can do using derivative instance equals new. We can have this in one liner. But with async disposal, well, we also could with async disposal, but how do we do configure await? Maybe, I'm now enabling this warning again, maybe we are in, either we build a general purpose library, so we don't know, because if we run in an UI application, for example, in WPF, we should use configure await. There is a lot of reasons to that, but not going into details. So now having the analyzer enable, the analyzer will actually complain, hey, we're not calling configure await on this awaited task. Actually not sure if this is even, yeah, I could do configure await here, false, but then this pattern falls apart because configure await is returning a configured async disposable. So I would need to do something like this. But now this instance is of a different type. I can't use, because what we saw in the derivative, we have this white method, but I don't have this white method available now. So with async disposable, we can't do it in a nice one-liner. We can't have our cake and eat it too, unfortunately. So we kind of need to split it into two lines where we declare it. So basically the kind of old-fashioned way, where we declare the instance and then do await using with the configure await. What am I doing wrong here? Derivative. Can I resolve instance? That's interesting. Oops. Is this just a... oh, yeah, there we go. My bad. Like so, we need braces because the derivative doesn't have configure await false. We need to get this async pattern. We need to call the what's it again? Get awaiter, which the await is doing. The get awaiter, and because the configure await. Oh no, actually that's on async disposable, not on the awaiter. No, okay, now I'm not sure why this doesn't work. Oh, because we don't declare the resource here.
Yeah.
This is not a using declaration, that's a using statement, and using statements have parentheses.
Gotcha.
And I guess we could now have like a block. And in this block, now use the instance. So this is now how we can write to it. And if we would have now an our resource as well, we could do, I guess that's the very same thing. We create our resource, then do an await using on the resource with configure await false. Then have a nested block here. And then in there, do the write, because maybe this write takes something from our resource. Yeah, I'm just making something up. But now in this inner block, we can use both resources. And should this one throw, we are in a block here. And the finally of derivative will be called. And we still deterministically clean up this unmanaged resource and don't put a gigabyte of memory, a lot of pressure on the GC, and everything is good.
Wow. That's pretty cool. So how much of this did you read in the documentation before you first built this? And how many of it did you figure out because things were breaking?
Well, I'm not doing .NET for like 15 years.
Yeah.
And I just understood the synchronous version. The synchronous version of the Dispose pattern just 2 weeks ago, because we actually had to build something around that. Is it cool? Should we show it? Maybe we can briefly show it. Do I find that quickly?
2 minutes.
2 minutes. If I quickly
we're only
find
an hour over time. It's fine.
Native, something with native.
Yep.
No, that's not it. Is that it? No. I thought it was. Is it transport? No. Okay, I don't think I find it. Closed. Oh, I should look in pull requests. There we go. 1 minute. I should be able to find it. Native. This one, yeah, I think. And before I didn't really understand the Dispose pattern, but in here we needed it because, let's find the tilde. There it is. Because we got an int pointer, we got some unmanaged resource that we get from, because our library here is layered. We have a managed.NET layer.
Yeah.
And if we run this on, for example, on an Android mobile phone, we also have some unmanaged layer to it that does stuff on the respective platform. And now our managed layer is using resources and owning resources from that unmanaged layer.
Mm-hmm.
And since our managed layer is the owner of it, it also must dispose of it. But the GC is not aware of any unmanaged resources that come from this layer. So we only have a pointer into this unmanaged layer, and then need to make sure that we free this again. And this is where we actually needed a pattern. And you will see the very same thing in the destructor, in the finalizer. We call dispose false. In the where is then our dispose method? We also do the object disposed exception if we would use it after we have disposed it. We have the Boolean one overload where we then free this unmanaged resource. We also do this interlock change. This is what I would like to exchange with a safe handle. And because the safe handle, I think, would also ensure that this object disposed exception, I think also, so we can get rid of a lot of code because the safe handle is taking care of it. And this is how I learned about the synchronous disposal, because we needed it. And
now you got it.
This type is sealed, but the type we are deriving from is not. And this is the one that implements iDisposable. So this base type here, and I think serializable with GB content again derives from something. And this very, very base type, or whatever first type in the hierarchy is implementing iDisposable, is now having this dispose pattern, having the public method that does suppress finalizer and offers this override Boolean method. And then we basically just wrap into this. And in here, we only have unmanaged resources. And since whenever disposed, where is it? Our dispose is called, since we don't have any unmanaged resources, since we don't have any managed resources, we don't have unmanaged resources, we just kill this. And yeah, if we would have also implemented the async dispose pattern, I should be able to also go for it without the documentation, but I never used the async dispose pattern so far. But yeah, I tried to learn it, but since I never really, really used it in a use case, I guess I haven't fully internalized it yet.
Yeah, fair enough.
If that answers the question in a more than 2 minute fashion.
It was about 4 minutes, so it was pretty good, pretty good. No, awesome.
And,
That's
well,
pretty cool.
I noticed it 10 minutes ago, but yeah, I guess that's how to close it.
Yeah.
Well, I guess being late is interesting with us because we are always over time anyway. So
Exactly.
I guess
We shouldn't
being
even be
late is
here anymore.
kind of really, yeah.
Yeah. Totally. No, but awesome. That was a really cool start into the new, I don't know, it's not a new season, but it's sort of like picking up this season, I guess, after a break. And especially because it was a really good topic, because I've been thinking about like the the language pattern for quite a while now. And so like seeing this the implementation, like from in all its intricacies and traps and things to think about, because I think like in my head, this is like one of the things that I struggle with sort of the most. I always like just hope that it works, and when it does that, I'm like super happy. But like to think about, okay, who might use this, how could this fail, you know, on the consumer side, or like whatever, or like in a larger picture. I sometimes really struggle to think about this. And then, you know, you also like I also try and read the documentation like top to bottom, but you know how it is. You always fly to the bits that interest you, and you sort of skip through the recommendations and blah blah a little bit. So this has been really cool to sort of like go at it with like the training wheels on, and and sort of your guidance. So thank you.
I'm uncertain what this emoji is, but I guess this is how one looks after the Dispose Pattern.
So yes, if you've joined us late, a summary of today's stream would be these three emojis. But yeah,
I guess that's also the confusing part of the word pattern, because I think there is kind of three there's kind of three meanings to pattern. We have the language patterns, where we have the using keyword that works in ref structs with having the dispose method available without any interface kind of a thing, or with how to for each everything and await everything. We have patterns in the term of a structure of methods, where you have a dispose method that calls these two and have a virtual and so on, so a bit of a library design patterns. And then is, of course, oops, I opened the wrong tab. Then there, of course, pattern matching, which is also patterns. And whenever we have something with is or switches and such. And I think my favorite pattern is actually the list pattern, where you can do something like that.
Yep.
And I guess then the emoji does indeed apply.
Yeah,
so
exactly.
What
I think it's
pattern
always
do you do?
because exactly, like because we also did this kind of in our talk, and there are a couple of sort of people who had this in our title, but it's one of those tricky things to have in a title, because everybody will read it and think of something else. Not everyone, but like, you know, there will be quite a few interpretations of the title, I guess.
Quite context sensitive, yeah.
It is, absolutely. Awesome. Well, we've had quite a few regulars on the show today, but if you are not yet a regular, you know the drill. Please like and subscribe if you are interested in our upcoming streams, and if you have any questions or feedback or things you'd like to learn more about, please also reach out. There's a list of all of our social medias. So yeah, give us a follow if you'd like to be updated about our upcoming streams, and if you have any questions, suggestions, anything like that. We always love to hear from you. And I guess, I mean,
I think
we're back in a.
My eyes start tearing up. So I guess that's the time to call it a day.
I know it's so sad to leave you. For tonight. We can barely.
I don't want to go home.
No, just one more pattern.
I can keep it. I'll be right back.
Okay. But yeah, we're now back in a bi-weekly fashion again. So definitely join us next time. And when is our next time?
Yeah, I haven't prepared the fancy drop down that we usually have because it's been a while and forgot everything.
Yeah.
Did we settle on the 9th, haven't February? So I think this will be Wednesday. I'll do it old school. The 9th of July, I believe, at 1700 UTC or 1900.
Yes. So basically,
CST.
9th of July. Yes, that's exactly it.
Some final messages. Stuart. Also
Stuart, hello.
Well, we did talk a bit about languages. So, well, C#14 is actually C#14 is closer in the future than C#13 is in the past. Do you know what I mean? Does this make sense? It's July, August, September, October, November. Just 4 more months, and it's C#14 time.
It is indeed. Time flies. And in C#14, don't we have a new pattern? Is that right? Yes. Collection.
Oh, yes. Collection expressions.
Dictionary. Dictionary expressions.
Dictionary expressions. So we'll also be able to.
We have collection expressions.
To apply the collection builder attribute on dictionary-like collections, which I think are basically enumerables over key value pairs. Not sure, but I guess Stuart knows the current design more exactly than I do. And we have a couple of late joiners. Well, it's definitely recorded.
Oh yes, exactly. If you want to watch any of our previous shows or this one,
Oh, I should post a link to our GitHub page where we also list links to our socials where we'll announce the content of the next episode when we have it ready. We still need to build up a bit of a pattern again of streaming every 2 weeks.
It's all gone. I don't know how this happens, but yeah.
And Lord Tupirian also joins us well, it's usually best to there was a saying, right? You need to stop when it's the most fun. Well, I'm actually crying, so maybe.
Yes. There's also this saying, it's like, you know, if you go on for too long, somebody will. In Germany, you have this, right? Bis einer weint.
Bis einer weint.
We've reached the point of people crying. So.
No, did you? Wow, it's been a while. I'm so out of the loop. Did you forget anything?
No, I don't think we forget anything except for saying thank you to everybody who's spent the evening with us. Thank you so much. It's really, really nice to have you back with us. And see you next time, I guess.
On the 9th of July, we'll be back.